Dear conferees, ladies and gentlemen, on site and online. Meine sehr verehrten Damen und Herren, liebe Kolleginnen und Kollegen, sowohl hier im Saal als auch im Online-Stream an dem Bildschirm. Sollten Sie heute den ersten Tag dabei sein, dann möchte ich...
If this is your first day here today at the conference, I would like to, of course, welcome you as well to the 14th International Motorcycle Conference of the IFZ. If you happen to have been here already yesterday, you already attended the dinner in the vicinity of the Cologne Dome. This is an aspect, of course, that we cannot cater to virtually. After those, after these very important talks, is a very special occasion. You have the opportunity to establish contact, to refreshen old memories, freshen old contacts, and that is a foundation for a good cooperation. Specifically, when all those attending share the same goal to improve motorcyclists' safety. What you can do here, you can observe also globally here. You can see how important international exchange is and how well it has progressed, how important it is to maintain these, retain these contacts. That is a recipe for success, which cannot be brought in line with isolation long term. From the point of view of cooperation between institutions, research institutes, and of course manufacturers, there will be a major highlight of the conference today at 2 p.m. when Antonio Perlot, the Secretary General of the European Association of Motorcycle Manufacturers, ASIM, will lead through the roundtable discussion entitled Vision 2030 Plus, the motorcycle industry's future within the EU mobility transformation. Ladies and gentlemen, in the context of a conference like this one here today, it is, of course, holding cold to Newcastle, but permit me nonetheless to stress how important it is to work evidence-based, communicate and inform evidence-based. Well, of course, first of all, the results of research, and basically that science and research are great achievement and cannot be arbitrarily replaced by opinion, prejudice, or anecdotal evidence. The world of powered two-wheeler is no exception to that. With all the emotionality that motorcyclists and scooters fortunately provide us with when it comes to this unique form of mobility, research from this aspect is indispensable. Of course, safety can only be had and improved if research is continued and intensified. This is taking place already in international cooperations and with the help of international research teams, as has been presented here at the conference, for example, with the example of the CMC. This way, experts from different perspectives concentrate on a certain problem and provide answers and enable a rapid progress and qualified results. These teams are supported by young researchers, and of course, when it is about continuing the long and successful history of improving safety on power two-wheelers, they are of course indispensable. For this reason, it is a great honor, and that brings me to the first highlight of today, by the way, that the FIM-Awards for young scientists are going to be awarded for the first time here within the frame of the International Motorcycle Conference. That gives me the pleasure to give the floor to Dimitri Margaritis from the Fédération Internationale de Motorcyclisme to present very special FIM Awards for science in motorcycle safety. However, I would like to, before I do, thank you for your attention and wish you a very pleasant and interesting and insightful second day of this conference. Thank you very much.
Good morning. Ladies and gentlemen, those that participating physically and those virtually, dear friends, because there are many friends here also joining this year IFZ conference. I'm very happy to introduce you the FIM Europe Awards for Young Researchers. Taking the opportunity of being here at this stage, I would like to thank IFZ colleagues which have welcomed this idea since the first discussions we had 2 months ago. These awards are part of an internal FIM Europe project that has been initiated since 2020, but unfortunately because of COVID, we could not realize it earlier. What is the idea behind that? We aim to support young people to participate in power two-wheelers research. We also try to encourage them to carry on in such specialized field as the motorcycle research is, and unfortunately those days not as popular as maybe 20 years ago was. And most importantly, we try to support them to realize their dreams, because working for motorcycles and working in motorcycle projects, it is a kind of dream. You have to be passionate in order to work with effort, as again said, in a field that is really specialized, even though really interesting and challenging. This year FIM Awards can be considered as a kickoff for future relevant initiatives on a European and we hope also on a global level. Also hoping that this will be adopted and also further supported by the manufacturers, the industry, the academia, research organizations, and the relevant stakeholders. This year awards is a kind of a financial support to the researchers, to the young researchers. So we set the first prize to 800 euros for the winner and 400 euros for the second prize. And then you might wonder, Dimitri, is that enough to realize your dreams? Of course not, but that's the first stage. We consider more challenging awards in the future. For example, a transit period in a manufacturer or also in the framework of or the environment of FIM. So there might be further ideas, and we are welcome also from all fields that you can propose to us and then try also to realize them, always aiming to help young researchers to carry on and to continue what we have started, some of us 20 or more than 20 years ago. I have to say that the number of young researchers was limited, unfortunately, at least those that they are linked to universities, to academia. We hope that this initiative of FIM Europe, FIM Global, and also IFZ will contribute to differentiate the number of young researchers participating in such important conferences in the future. So let's, I don't want to be to keep this speech longer. Let's welcome the two winners. The first winner is Abdul Karim Ait Moulin from LMA from France, who is supervised by Thierry, and he has presented his work yesterday on the estimation of power two-wheelers RH benefits working with accident data. Please, Abdul. You have to come to this side. Congratulations. Thank you. For your nice job, and we wish you all the best, of course, for the future.
Thank you, sir. Thank you. Thank you.
The second winner is Raúl Aranda-Marco from the LMU, the Medical University of Munich, and Raúl is supervised by Stefan, his professor. Raúl, please. Congratulations. You're welcome. So, by this, I wish to the two winners, as well, I think, as all of you, a successful finalization of their PhD studies, which is really a hard effort for those that we have done that, and also a bright future in the PDW field. Thank you very much.
Can we have the presenters come up for the first session, please? My name is Ray Ochs, and I'm from the Motorcycle Safety Foundation. I'm honored to be the chair of the first session today. We have 4 presentations with 6 presenters, so it's fairly jam-packed. As per usual, if you do have any questions after each presentation, there's microphones in the middle, and if you do have a question or comment, please state your name and affiliation at the beginning. So let us begin. Our first presenter is Dietmar Otte from Germany. He's professor and director of BIOMED-TEC, where he is an engineer and scientist in biomechanics. He focuses on accident analysis and reconstruction, including perspectives from forensic and scientific fields, particularly oriented toward technical and medical perspectives. His topic is aspects of accident avoidance for overtaking motorcycles in maneuvers with left-turning cars. The floor is yours.
Thank you very much, Ray, and it is a pleasure to be here, and I apologize that I will talk in German instead of English. Jeder kennt eigentlich als
Each of you
Motorradfahrer
know
die Situation,
this, as a biker, this situation. You want to overtake a car, and then all of a sudden this car wants to turn left. And there are frequent accidents in this process. And legally you have a certain disadvantage. You have Article 9 of the Road Transport Code providing for a double looking back obligation. The car driver, if you want to turn left, when you start turning left, you have to look in the rearview mirror. And secondly, you have to look again before you cross the center line. Now, this situation would be obvious had we not the reversal of evidence obligation legally. If the overtaking vehicle might make a mistake, for example, by driving too fast. And that is the situation where then we have frequently then situations where you end before court. We have investigated this on the basis of a situation where I was an expert opinionator at the court. And so we did a assessment we checked the GIDAS data, that's representative data collected by an interdisciplinary research team by the medical school in Hannover and Technical University at Dresden, on behalf of the German automobile industry and authorities in Germany. It's not just the automotive industry, it is all the two-wheeler industry that uses the GDAS data respectively. So we checked accident data between 2009 and 2018. That was motorcycle above 125 cubic centimeter. It was a total of 2,108 accidents. We selected cases where the motorcycles overtook or drove in parallel to the car and then had to cross the trajectory of the car. It's difficult to establish because these accidents are treated a bit odd in the accident statistics. You see here all the accident types, 169 different types of accidents. Of course, we were interested in the left-turning cars and the U-turning cars, and ended up with 54 cases that we then assessed. It's not too many, but we then had a very detailed analysis of these accidents because there were sketches there was pictures of vehicle deformations, etc., and there was ample documentation, so these accidents could be reconstructed. Just basically on the epidemiology of these 52 cases, you see that with these left-turning cars, it's basically within city limits. It is 44%, then country roads 37%, of course national roads left-turning, or at the motorways is zero, because of course there's no possibility to turn. Just look at the police documentation. Only in 30% of the case it was the biker's case. In 70% it was the car driver. Nonetheless, 30% is very high for motorcyclists, and we have to think, how can we bring these numbers down? The speed at the accident site was 30% of the city limit cases. Here there was the speed limits were exceeded. Of course, this is a potential that you can tap. We'll come back to that at conclusions. It is 75% motorcycles between 500 and 1,000 cubic centimeters, and age of the motorcyclists you can see here on the average here is between 26 and 45. So the main group is of middle age. The severity of the injury is, of course, heavy. You can see that for the left-turning accident here. This is a classification of severity of injuries according to AI1. MICE 0 is light, MICE is more heavy injury, and MICE 6 is deadly. So we have not so many numbers of heavily injured, but MICE 2, 31% is to be considered here, because that would include all broken bones, for example. Compared with all motorcycles, and that's the interesting thing about this, how risky is it here in the case of left-turning cars and overtaking motorcycles? The injury severity is higher in the case of these kinds of accidents.
Und besonders häufig
what is specifically injured is, of course, thorax and legs, and of course arms, 30% here. Well, it's basically IS2, but it's still quite frequently. These are the injuries here: thorax, legs, other extremities as well, frequently with the long-term consequences involved here. The collision speeds, 80% is 60-70 on average. Well, it's owed to basically that these accidents are most frequent within city limits, but motorcyclists frequently rode faster than 64 kilometers. So here we have reduction potential. The precise accident reconciliation was possible for each individual case, and that's we looked at the distance-time relation, or limited our assessment to distance-time relations. We tried before collision to go 5 seconds back, as much as this was possible through surveys, through testimony, etc., in order to consider this distance-time relation, and did a PC crash analysis. You can see that here in this animated picture here. Of course, this is a slow-mo version of it. And these distance and time graphs we juxtapose both for the car and the bike, and we saw that from the overtaking, start of overtaking to crossing the central line, maximum 3 seconds, 2.2 seconds, some. So that is basically the time that the car driver needs for this turning movement or process. And if you then look at when the biker starts overtaking, you see that until the car crossed the center line, the biker already started overtaking, i.e. the car could have seen the biker. This is then depicted in minus. Yeah, it's very important then that during this time span, the car would have been obligated to look in the rearview mirror and check what's happening there. So until 4 seconds, it would have been possible for the car driver to stop turning. You have this case here. You see a biker passing through a city. Then it was the end, the city limits, and there was a group of bikes before him, 5 cars in total, which you wanted to overtake, because now you were on the country road and they were before him, and you wanted to overtake, passing the city limits, and the first of those 5 cars all of a sudden turned left, and there was a collision. The damage you can see here: collision, left here fender, exactly there where the car started crossing the center line. If you have sufficient traces, you can reconstruct the accident easily. You see what happened in slow-mo. There was the coalition, the biker flew to the side and landed in the field. The PC crash analysis that we conducted can put the camera in various different angles, and you see here from the front the bicycle hit a post while the biker landed here. It was heavy injuries, head, and lots of trauma in thorax and legs. Time analysis showed that the motorcyclist crossed the central line 2.5 seconds, so he was visible for the car driver 2.5 seconds that he was on the opposite lane. So that shows avoidability for both the biker, who could have stopped overtaking, but also the car driver. Of course, at this moment, had he broken at this point, the collision would have couldn't have been avoided anyways. So you can look at the situation how the biker saw this whole thing. He took over. And only now you see here the car starts crossing the center. Now he should have reacted, but he didn't. Maybe could have swerved to the left, but you know that a biker needs some time for swerving because of the shift of the center of gravity. But the view for the car driver is a different one. If you look constantly into the rear view mirror, these were 2.5 seconds before collision. He should have seen the biker in the rear mirror. Had he now even shortly before crossing the center line reacted, didn't drive fast anyways, could have broken, and he could have gotten back into his lane and could have avoided the collision. This is what the distance-time relation shows us as well. On the left, the black graph is the cyclist here in distance-time relation and 20 meters before collision. Could have spotted the car driver's intention to turn left. There's a bit of a problem here with there's been some shift, says the speaker here of the graph. So had he reacted? You see the green graph here coming up. That is the braking process of the car. Had he broken, he could have stopped the car 3 meters before crossing the center line. So both could have avoided the accident. No. Overall, analyzing the 454 cases, had the bike reacted properly, or had the bikers reacted, only 24% of the accidents could have been avoided. 76% of these accidents couldn't have been avoided because of the lack of scope, of distance. The situation for the car driver is completely different. In almost 60% of the cases, these accidents could have been avoided, and if you had frequently checked the rearview mirror. Almost 100% of these accidents could have been avoided. So our objective is to have a constant look at the rear view mirror. But what we need, therefore, is an assistance system which looks at the mirrors in the car and in braking the turning transaction, or issuing a signal, a warning for the car driver to react. Of course, it would also be helpful
dieses Blinkersetzen dann auch von dem Assistenzsystem entsprechend schon registriert
if the indicator could be included in the warning system. The time lapse is sufficient, as the analysis shows. The motorcyclist has up to 3 seconds for the overtaking in these 54 cases, and the car driver up to 2 seconds to stop. So predestined for an assistance system. If we look at this, it helps us to avoid these accidents with the help of these technical assistance measures. So motorcycles should not overtake in critical situations as long vehicle convoys, and there's always conflict because the traffic code is such that you have a reversal of evidence obligation if there's one traffic participant's fault, and that is frequently the case with the bikers, that you assume that they were too fast, and for the motorcyclist that overtakes and has a higher speed than the car, only to a 20% you have the possibility to avoid the accidents, because this crossing the center line can only be detected at a very late stage. And so you could ask the legislator
Abbiegevorgang in brenzligen Situationen wie hier war ja Geschwindigkeitsreduzierung von 100 Kilometer pro Stunde. Nach Ortsdurchfahrt konnte er sich frei bewegen, da konnte er schneller fahren. Aber dann kam der Einmündungsbereich.
Well, you have had this situation where you had then crossing the city limits, you see the 70 kilometer sign, he rode 75 kilometers. Well, you could discuss now with the legislator whether you shouldn't put a prohibition of overtaking sign at the end of city limits, whether this could be installed here and there. But be it as it may, assistance systems could always help to avoid these accidents. So having said that, I would like to thank you for your attention.
All right, thank you very much. Very interesting.
Ja, vielen Dank.
Do we have any questions? Yes, please step to the microphone and please name and affiliation.
Good morning, Sebastian Will from WVW.
Sebastian Will,
Vielen Dank, Herr Otte.
Thanks, Mr. Otte. I have a question. You talked about a appropriate situation of the biker in your accident. So what is appropriate reaction? For the response time of the biker, we had 0.8 seconds for an appropriate response, because you have a certain expectation at this point. If a biker overtakes, you cannot talk about a prolonged response time or reaction time. Of course, you have to consider with all these things here, this is assumptions that you make. The these until the crossing of the center line. When you come to the accident site, you have the cars and the vehicles lying around, and you have to establish how the situation was. Here, in many cases, we had the advantage, also in the case that I presented, that there was a case before court, and there were these proceedings where the individual traffic participants were questioned, were investigated, were heard before court. So, of course, you have various different assumptions in all of these 54 cases. That's why we made our assumptions. And regarding to your question regarding the response time, it was 0.8 seconds for an appropriate driver, cycler respond. First question. On the question, did the car driver indicated his intention to turn left? That would have been an essential information. Second question, a warning system, would these warning systems in the mirror also be useful for dooring accidents? Because that would be a similar situation, only slower. On the last question, for bicyclists and motorcyclists, for those situations, we have these assistance systems already. That's why I am confident that you have these assistance systems also for these rearview mirrors for bikers. We have had these systems for longer. And also for bicycle paths, etc. This has already been implemented. Whether the indicator was used couldn't be established in this specific case. So the car driver, in the first statement before, in the police report, he said that he can't remember whether he indicated or not. He thought he indicated, but then the lawyer came and he said, no, of course he indicated. And be that as it may, the proceedings have made clear that this reversal of evidence kicks in. That's why I was called before court as an expert in order to establish the speed of a biker. And the 50 or 70 kilometers were not so much considered by the judge, 70 or 75, because 5 kilometers more is not a strong exceeding of the two. But one really considered that the bike was too fast. But in this case, it was appealed and went before the Supreme Court. Because they said, well, the first evidence is that before you start indicating and before you're crossing the line, the second evidence is during the turning process, but not when crossing the center line. When the center line is crossed, had the car driver still looked at the rear view, he could have still avoided the accident. So the lawyers then claimed of the biker said that there is a constant rear view mirror use obligation, and that the car driver would have been obligated to look before in the rearview mirror again before crossing the center line. And then the judges said the car driver was given 80% of the guilt. So these are conflictive things that could have been avoided with the respective technology. From Bosch now here, Matthias Müller, can't you see more potential for car communication in future by car driver already being informed about the intention of the biker's intention to overtake? Yes, I agree. If you indicate as a car driver, you could have already been given the information from the car, from the biker, that there's intention to overtake. So that is, you could say car-to-car communication, but vehicle-to-vehicle communication. That would be the possibility. And I recall my GIDA's work. I assessed accidents, and the result was that 70% of the accidents could have been avoided by car-to-car communication, or effects of accidents could have been mitigated, say, at least. Thank you for the question. Good question.
Okay, thank you very much. Very interesting area where there's certainly room for improvement. Okay, our next presenter is Raúl Aranda-Marco. He is a mechanical engineer who works in biomechanics and accident analysis for the Institute of Legal Medicine, University of Munich. As a researcher and PhD candidate, he studies the impact of biomechanics via crash simulations. Interestingly, he participated at the student competition Moto Student at the University of Zaragoza in Spain, where he earned his Master of Science in Mechanical Engineering. So please begin.
Yeah, good morning for everybody. My name is Raúl Aranda, and I'm currently working at the University of Munich, LMU, and I'm going to present you in the next slides the following research: improvement of the frontal thorax airbag test procedures for assessing the protection of motorcyclists in a more realistic impact scenario. This research was part of the BIOMED-TEC project research activities, and this project was focused on improvement of the rider safety. Firstly, let me give you a brief overview about the presentation. I will start my presentation talking about the significance of thorax injuries in motorcycle accidents, and then I will explain the current test procedure to evaluate thorax protectors. Then I will explain two different preliminary test methods developed within BIOMED-TEC for the assessment of the protection performance of thorax airbags devices. And finally, I will conclude with a brief summary. Some factors like their poor visibility, their inherent instability, and especially their limited structural protection make power two-wheelers one of the most dangerous modes of transportation, which in the end it is translated in a higher risk of fatal accident. Taking a look at some statistics, motorcyclists and moped users accounted for 28% of all world traffic accidents in 2018, 70% of the total accidents in the European Union. If we get closer, in 2018, only in Germany, 619 riders died and 10,220 were severely injured. Looking into the location of the injuries suffered by the riders, the lower extremity are the most frequently body region injured, but the thorax and the head are the most severe regions injured. Focusing on the thorax, despite it is only the fourth most frequently body region injured, the thorax presents the highest rate of MAIS3 plus injuries, more than 50%. This point is also remarked by other authors, like Scherer, who in his study reported that more than 50% of the AIS4 plus injuries were located in the thorax. For those who are not familiarized with the AIS scale, an AIS4 plus injury means a severe, a critical, or a fatal injury. To protect the thorax, the main passive safety solution is the use of personal protective equipment. For the case of the thorax, there are two types, a non-inflatable and an inflatable protector. A non-inflatable is usually a cushion or a foot pump covering the thorax, and an inflatable protector is an airbag usually integrated in a jacket or a vest, which in case of accident will be mechanically or electronically activated. Most of the inflatable protectors available on the market today meet the performance requirement of the European standard EN 6021-4. To be certified according to this standard, an airbag must fulfill the requirements established by this standard in terms of an impact force attenuation test, intervention time, and duration of the inflated status. Going into detail of the impact force attenuation test, which is the part of the standard which evaluates the protection performance of the airbag, a 5 kg striker hits the airbag placed over an anvil steel at an impact speed of 4.5 meters per second, around 16 kilometers per hour. Depending on the force transmitted measured in a load cell situated under the steel anvil, the airbag will be classified as level 1 or level 2 protector. However, some doubts have emerged about the suitability of this standard alone to evaluate airbag protectors for the thorax. Firstly, it presents a low biofidelity. The standard procedure represents an impact between two rigid bodies, but in the reality occurs an impact between a deformable body, which is the human body, and a rigid body, an object or an obstacle. So, in this test, the human body is not represented. Secondly, the impact energy level of the test procedure is considerably less than the impact energy level present in a real accident. Thirdly, the original background of the force transmitted thresholds to classify the airbags in levels of protection is completely unknown. In addition, some authors point out that the test procedure presents some limitations to distinguish the optimal thickness-pressure combination for a better protection. And finally, only the cable trigger devices are considered and not the autonomous trigger devices. To improve the evaluation of the protection performance of thorax airbags, two test procedures were preliminarily developed within pioneers. Let's see the first one. The first test method was implemented as a complement to the actual standard procedure in order to improve the protection performance in a short midterm. After inter-discussions, it was agreed that this new test method should be as simple as possible, robust, repeatable, and of course more biofidelic and more realistic than the current procedure. We decided for a drop tower construction where a mast could be vertically guided in a free fall. The striker will be implemented as a modular mast to make possible the variation of this mast. The striker will impact a human surrogate equipped with an airbag already inflated, situated at the bottom of the test setup. Therefore, this test method will be only focused on the evaluation of the impact attenuation performance and will not analyze the inflation phase of the airbag. To make this procedure more biofidelic, instead of a steel anvil, we decided to use the torso hybrid 3 dummy as a human surrogate. We chose this surrogate because the hybrid 3 dummy is an anthropologic test device extensively used in automotive field and therefore well known. The torso of the hybrid 3 dummy is equipped with a transducer which makes possible to measure the thorax compression during an impact. In order to define more realistic impact conditions, we conducted an analysis of our internal accident data. We identified 3 frequent impact conditions, or 3 clusters, which concentrate many accidents. In the first one, a rider will impact a reed plane, which is mostly the ground, at around an impact speed of 3 meters per second. The second one, a rider will impact a cylinder from 5 to 10 centimeter radius at an impact speed of 7 meters per second. And in the third one, the rider will impact a reed impactor with a radius between 5 and 25 centimeters at an impact speed between 13 and 17 meters per second. For the implementation of the test procedure, we only consider the first 2 conditions, because the third one was considered as a very severe for this initial stage. Another point to define was the mass of the striker. In the test method proposed, the striker impacts the human surrogate. That means that an object impacts the rider, but in the reality occurs the inverse configuration. The rider is who impacts an object. In order to generate an impact situation as realistic as possible, the mass of the striker should be equivalent to those portions of the mass of the rider involved in the impact situation in order to obtain the same thorax response. For that purpose, some simulations were conducted with different values of impact mass, and the thorax compression responses were compared with that thorax response calculated in the simulation of the rider-to-object impact configuration, obtaining around 35 kilograms. This point introduced a limitation to our test procedure. The thorax deflection obtained for the equivalent mass was 102 millimeters. However, the construction of the torso of a hybrid 3 dummy allows a maximal compression from 60 to 70 millimeters without breaking the device. For that reason, the final impact conditions must be adapted to those ones which maximize the impact energy, but of course without breaking the dummy. Our proposal is to evaluate the protection performance based on biomechanical parameters and criteria. For this case, the protection performance will be evaluated according to two criteria, the compression criteria and the viscous criteria. The first one, based on the experiments with BIOMED-TEC conducted by Kroll, refers to skeletal injuries, and to this criteria is necessary to measure the thorax compression or thorax deflection. The second one, based on the experiments with BIOMED-TEC conducted by Biano, considers the rate dependency and compression dependency of soft tissue injuries. Both criteria refers to the response of a human thorax. However, as the hybrid 3 dummy is an extensively known human surrogate, it is possible to apply this criteria considering the measurements provided by the hybrid 3 dummy. The measurement of the external compression and the calculation of the viscous response could be used together with the existing hybrid 3 dummy curves of injury risk probability to establish and determine the levels of protection of the airbag devices. Now, let's see the second test method developed within pioneers and proposed as a long-term procedure. The requirements considered for the second test method were it should be possible to evaluate the airbag protection performance, but also the inflation phase of the airbag. It should be a test which allows to evaluate mechanically triggered airbags as well as electronically triggered devices. It should represent a rider-to-object configuration, and the evaluation of the protection performance of the airbag should be based on biomechanical parameter and criteria. So here, the test procedure, the test setup. This test procedure consists on a drop tower system where a guided moving platform will carry the human surrogate equipped with the airbag device. In this case, as in the previous test method, the human surrogate will be a hybrid 3 dummy torso. When the platform is unhooked, the platform will fall until it reaches the braking system, where the dummy will be released. The braking system for the platform will also generate the input signal for the activation of the airbag. Once the dummy is released, it will fall freely to impact a flat striker position at the bottom of the test setup. The airbag's inflation will be evaluated using a high-speed camera. To evaluate the protection performance of the airbag, the dummy instrumentation will be used, as in the first test method, to calculate the thorax deflection and the posterior viscous response, and also their corresponding injury risk probability. Of course, this preliminary test procedure has also some limitations to deal with. Firstly, a rider-to-object configuration test implies more moving parts, so it is a more realistic test, but also is a test with a higher technical complexity. Secondly, the mass of the hybrid 3 dummy torso is around 19 kilograms. And as we saw before, it might not be close to the mass of the rider involved, to the portion of the mass of the rider involved in a real accident. So now let's summarize. The doubts emerged about the current standard procedure together with its limitations motivated the research of a new test procedure for the performance evaluation of thorax airbags. Facing this point, the Pioneers project proposed two different approaches looking for a more realistic and biofidel analysis of the protection performance of airbag devices. The first one is a test which could complement the N6021 in a short midterm time. And the second one is a procedure to evaluate inflatable devices able to combine the evaluation of the protection performance and with the assessment of the inflation phase in a real impact situation. As I mentioned before at the beginning of the presentation, this research was part of the Pioneers project, and I invite you to take a look to the website to take a look to this study and others about improvement of the rider safety. This project was funded by the Horizon 2020 program, and I would like to thank all the project partners for their work and collaboration. Thank you very much for your attention, and you have questions.
Thank you. Very fascinating information. Do we have any questions from the floor? Yes, please. Move to the microphone.
Good morning, Colin Ballantyne from KTM. So in most of the 1621 series of standards, you have multiple impact points when you make the assessment, also for the helmets. In this procedure that you're outlining here, are you proposing only to have one single impact always in the centre of the chest, or is the torso of the device going to be adjusted to the other parts of the chest? And how does that deal with the instrumentation inside the Hybrid 3 chest?
Are you talking about the first test method?
It would apply to both.
Okay. In the second test method, the Hybrid 3 falls freely, so it will be only one impact configuration in the second test procedure. In the first one, it is possible to change the orientation of the striker to hit the dummy not only horizontally but also diagonally, or if you want vertically, but that is not. But the impact point at this first stage would be only the center of the thorax, which is where the transducer is positioned in the Hybrid 3 dummy, in order to obtain a not modified measurement of the Hybrid 3 dummy. So it will be only here. I think the transducer is more or less in the middle of the sternum.
So the impacts would be always limited to the centre of the chest?
Yeah, but it is a limitation imposed by the Hybrid 3 dummy because the transducer is that position. So we could impact to another point, but maybe the measurement will be not so accurate, or I'm not sure we could rely on this measurement.
Okay, thank you.
You're welcome.
May I ask also a question? Oh, sorry.
It's on.
It's on. Okay.
Yep.
You used accident data for validation, and is it also, can you say something about how you have considered the internal injuries, or did you look only to the rib flexion inside?
No, we consider thorax injuries. Well, I'm not very familiar with our database, but we consider the AIS 4+ injuries, and we filter them depending on the impact, the speed, and the obstacle, the impact object, the striker.
But if you use accident data, then you have a very huge distribution of impact situations.
Yes.
And
there were a lot.
How you could focus on...
Yeah, we focus on these points where the accidents were concentrated. So we identified this kind of 2-3 clusters where more accidents were concentrated. That doesn't mean that there were not other accidents out of these regions or intervals of speed.
But it's difficult.
Yeah, of course, it's difficult. Yes?
Yes. Can you hear me? Yes.
Yeah, yes.
So, Oscar Cherta from Motion. I was wondering if you compared the performance of the airbag or chest protector using your new protocol with the testing procedures proposed in the 6021 series?
No, we conducted just a few tests with the new procedures. The project was finished. We didn't have time to test a little bit. We test a lot, sorry.
Okay, thank you.
You're welcome.
Couple quick questions I've got are, is there any test for sliding? Do you get into that at all, or is that a whole different testing procedure? The wearability, the durability in a slide, and then it may have an impact after that. Is there any testing for that you're aware of?
No.
If I may, every airbag motorcycle garments have to be certified under the new PP for motorcycle garments, which is the 17092, and the abrasion resistance is part of the test. So in terms of how does an airbag behave during a sliding phase, if a crash lasts like 3 to 5 seconds, is more driven by the garments around the cushion, the cushion itself.
Thank you.
We only focus on the protection performance, not on the abrasion.
And also the integrity of the helmet, where the helmet will not move once the airbag is inflated. Is that tested at all?
Very good questions. Body shapes, different type of helmets driving this, different shape of cushions that lift the cushion around the neck. So there is different options today. In our case, we lift halfway on the neck to limit the movement of the neck, but avoid fully fixed cushion systems that may impact if the cushion lifts too up, too high, someone which is a small neck and a big fully integrated helmet, full face helmet.
All right, thank you. Anyone else? All right, thank you, Raúl. Appreciate the specifics about a frontal thorax impact. And with that, we'll move to the next two presenters with their topic. First we have Pierre-François Tissot from France. He is a mechanical engineer and chief of sales officer in Motion, which he co-founded and vice president. He is active in the smart wearable industry, especially in motorcycles. He is a French expert for personal protective equipment, and since 2015 has been involved with the European Standards Committee for motorcycle garments. Sharing the podium with him is Oscar Cherta Ballester. He is a mechanical engineer and PhD in injury biomechanics. He is also an expert and associated with the EU Standards Committee. Their topic, smart wearable airbags, benefits for users and remaining challenges after 60,000 kilometers and 3,000 accidents. And I understand you go by PAF sometimes. So.
Thank you, Mr. Chairman. Yeah, people used to call me PEF. Well, it's easy to remember. It's the noise of the airbag when it deploys. So basically, I'm very happy to present this sum up of learnings based on 60 million of kilometers. There was a small typo and not 60,000. And I want to thank my co-authors and Oscar and Valentine's, my partners. Before we go more into data, one thing that feeds us at InMotion every day is trying to save lives. And we used to say that even if we saved one life, well enough. And we used to have testimonies that comes almost every day from people. I just wanted to share one from Didier that crashed a few weeks ago on a high side on a highway. And something that even touched me as a father says, I was happy to hug my little daughter in the evening. So just after a lot of data before and after, bring back of we try to save people. For InMotion, coming to this conference was very logical, and I would say was not a big job to do a dedicated presentations because the naming was already close to us. I've checked yesterday that few of you guys was not very aware on everything about airbags. So a few words about InMotion. I've co-founded this company with two friends and partners, engineers, back in 2014. We are a company which is specialized into smart wearable airbags. We even used to call wearbags, which is the contraction of wearable airbags. We have today a team of more than 60 experts working exclusively on this topic. which is probably the biggest team in the world. We started to equip some professional skiers back in 2015, and still now Olympic winners and guys like this. Then we moved to horse riders, MotoGP racers, and now a big group of, or any type of, let's say, motorcyclists. Especially now we can share that we have more than 55,000 users, and we are working with 9 different partners. So a short also introduction about our concept. We produce everything related to the system. So the in-end box is the brain of the systems that get all these sensors fully embedded into the garments, and everything related to the cushion, the inflator cushions. Everything are all together put into a garment, and that's where we are supplying partner brands. So you can see one of the most famous European motorcycle gear brand, which are integrated our system into their garments, which are sold in a shop, any type of motorcycle shops, and then used by a motorcyclist. And the chance is we keep the connection with the end users, with the smartphone and Wi-Fi connections. So we are collecting data user account and data real riding situation for every of our users. On the other side, we of course use this data to get the systems better and provide regular updates, evolution of the system, and so on. So our systems are connected, and these connections will drive a lot of knowledge on our systems.
So our main target are motorcyclists, because Raúl explained very well before, but they represent an important proportion of road traffic fatalities in the world and the European Union. And regarding injuries, the thorax is one of the most severely injured body regions. So there is a real need to protect motorcyclists, in particular the trunk, the thorax, with wearable protectors. Why wearable protectors? Because during the accident, the motorcyclist fall or is ejected from the bike, and all the body regions are exposed to multiple and multidirectional impacts. Okay, thank you. Regarding the available PPEs for motorcyclists, we can see that the airbag is the only safety device capable of absorbing impacts on the trunk, on the thorax, abdomen, and the spine. However, the wearing rates of these safety devices are still low compared to other PPEs, such as the helmet, jackets, gloves. We observed that these wearing rates are linked with the date of creation of each technology, so we can imagine that in the following years the use of airbag will increase. And today we are going to show you, to explain what are which is the evolution of the airbag in the last years, in particular in terms of diffusion, product availability, the usage for this technology, and also the mentality evolution of the final user. For this, we combine 2 approaches. The first one is an overall analysis of the airbag ecosystem based on our experience in the field of protective clothing. Also, we are experts in the European Committee of Standardization. We have also the feedback from partner brands of motorcycle clothing, as PF explained before, retailers, insurances, and also information coming from elite motorcycle riders on track and off-road races. The second part was a survey in order to obtain information about the population that uses the airbag every day. So last year we sent a questionnaire to our users in order to obtain data about the user profile, their riding experience, habits, which is their level of safety equipment, and also the usage and their opinion about the airbag. So let's now continue with the results.
Thank you, Oscar. So just a quick overview of what happened in the last years in terms of smart airbag technologies. Basically, the first, what we call mechanically triggered airbags arrived and were available on the markets around 1998. And then we see arrive in 2012 some systems which was required to put sensors on the motorcycles to trigger the systems, which was called electronic radio airbags. And these systems has been almost discontinued in favor of what we call fully autonomous systems. Fully autonomous is the system itself take all the sensors, inflators, and don't need any connections with the motorcycles. So those fully autonomous systems are available on the market since for almost 7 years. And we see the difference of the market shares now in 2022. Basically in France, it's 80-50, 80% are electronic autonomous airbags, 20 on mechanical airbags, and on Europe, based on estimation, is 2/3 for electronic airbags, 1/3 for mechanicals. On the two charts down on the slides, you can see on the red parts the number of companies which are claiming to work on let's say, wearable airbags. And you can see a major increase with a tipping point in 2015. We are now around 35 companies that work on wearable airbags. So let's say there is choices. And on the left side, the most driven, let's say, application for wearable airbag is motorcycle, with more than half of those companies which are working in this field. So it's exciting to see that with more actors, that bring more innovation and competition. So now how to explain where are we, let's say, in terms of diffusion of airbags, and how to explain this diffusion in the last years. The first point is the increment of availability of the product. Basically, we can say that France is probably one of the most mature markets in terms of use of wearable airbags. But if you take the top 3 manufacturers of wearable airbags, which are Motion, Dainese, and Alpinestars, altogether have product in more than 2,000 point of sales in Europe. And if we just do the focus in France, we're speaking about 700 point of sales versus 160 in 2014. So airbags came from something which was new and niche, to something which is a must-have in a motorcycle shop today. And you can find airbags in motorcycle shops, in specialized motorcycle gear shops, and of course every pure e-commerce dealers. This is what you can find today if you write smart airbags on Google. So you have kind of a choice, and that's also part of the explanations. You have smart vests which can be worn underneath the jacket, or above your jacket or your garments. You have jacket that can be turned into a vest, and you have fully integrated garments that come from adventure clothing, leather jackets, up to fully integrated race suits. And to give you an idea, one of the most lightest airbag vests starts at 1,300 grams, including the back protector. So the extra weight of the airbag cushion is around 800 grams. So 9 brands and more than 40 available references. I don't even count colors and sizes today on the market. So first point was the availability of product. The second point is the price drop. First, electronic airbag systems were released with a price above 1,000 euro, which is the retail price, which was quite expensive despite all the benefits of production it can brings. And you can see that year after year, the prices have been done to around 500-600 euro, and makes the systems much more affordable. And we even have at Motion a business model that let people buy or rent the systems. The price entry point for one of our vests is 350 euro, which comes very low. And we have now even partnership with insurance that co-finance part of the airbag for the motorcyclist. Then it's the good transition for the third part, which is we are all involved into the diffusion of such safety devices. If we take the example of France, more than 50% of motorcyclist riders in France can get a discount from their insurance to buy an airbag vest. And almost every insurance company are financing the reactivation of an airbag after a crash. There is also a big role played by federations. Sports is the competition is always at the forefront in terms of performances and also in predictions. Airbags are mandatory in MotoGP all classes since 2018. The same for the Italian Championship and the Junior GP Championship in Spain. And since 2 years now, airbags are mandatory in Dakar and Rally Raid. So the FIM were very at the forefront on this position. And we can see already impact in terms of protection with the airbags, because like 50% of the thorax injuries in Dakar have been reduced since the use of the airbag. The last point is governments. We see, especially in France and in Spain, those governments invested kind of good budget, more than €1 million of communication around the promotion of airbags. So the three major drivers of the diffusion of the technology were the availability of product, the price drop, and the involvement of third parties. Now, what can we learn about the use of our systems? As I was saying in the beginning, we are selling airbag for 4 years. We have produced 120,000 airbags for motorcyclists in 4 years. So what are the feedbacks we can get from our users? We did a survey last year, and we got about 20% of our users answering. So you have here the major information about those guys, so mainly male, an average age of 46 years old. And what we can learn at the first point is not a big surprise, but people are willing to wear motorcycle airbags, have a high riding experience. More than half have more than 5 years experience. They used to ride all the year versus occasional riders, so they know what it is to ride with bad conditions, rain, sometimes even snow. And they used to ride more than the average of motorcyclists, because they ride more than 5,000 kilometers when the average in France is around 3,500. The second key result is that there are a type of guys that are using a lot of PPE. I mean, once again, not a big surprise, of course. Wearable helmets are at 100%, but you can see gloves, trousers, pants and boots are more than half of them are using them. And if we are back on airbags, we can see that 90% of our users were not wearing an airbag before. So we are really speaking about newcomers. It's something that comes from zero. They were not using any airbag before. And the few of them which were using airbags were using at 75% mechanical airbags and at 25% electronic airbags. And when we asked them what was the driver, what was the key arguments that make you buy an airbag, and especially in motion systems, the top one answers was, it's an autonomous system. It means I don't need to connect anything to my bike and can use it with any type of motorcycles. I don't have to change anything on my motorcycles. The second key arguments are, it can be worn under my jacket. So it's funny to remember that we all focus about safety, but then it comes on a safety product or protective garments have to be worn. And to be worn, it has to be nice, it has to be comfortable, it has to make you look as cool as before. So having an airbag that can be worn under your jacket, you don't jeopardize your style. And then, I mean, a bit too bad for us, which are tech geek and tech focus, the production performances, the time of inflation, all of those which are where we fight every day in terms of technology, was a very low decision maker in their choice. Then one of the last learning is, we asked them on the bench how much of them has an accident, and 10% of the people that answers already crashed with the airbags, and 91% of them says that the airbag was feel like very as a bonus of protection, was useful, and 60% of them thinks that the airbag should probably have reduced the injuries. And we still have few guys that says that they crashed and the airbag didn't deploy, because we don't have, today, we have a 95% coverage ratio. On 100 crash, we can cover 95. And the last question, which is very important for us, is, on those guys, how many of you are going to ride without an airbag? And less than 5% thinks that they can ride without an airbag. So there is a before and after. And even more, 65% didn't even think to ride without an airbag anymore. And we just did this survey this summer in US, where the use of PPE is not as regulated than in Europe. And this value comes from 5 to 10%. So still in the US, we have 90% of our users think that they will never ride without an airbag anymore.
Yeah, so to conclude and summarize all this information, regarding the wearback acceleration, we have seen that the prices of electronic system has been reduced by 50%. There was a massive dissemination, increasing the point of sales in Europe and in France. Also promotional campaigns from governments and the obligation of wearing these safety devices in many disciplines. In terms of user profile, the population wearing the airbag every day, we see that the airbag are experienced motorcycle, well equipped, which rides almost all the year, and which are satisfied with the product because the end of use are below 5%. Finally, considering the effectiveness, we have calculated 91% of detection and inflation rate for our system. That means that in 91% of accidents, we can detect and inflate the airbag to protect the rider before the impact. 61% of people that have already had an accident with the airbag thinks that the airbag have avoided injuries, which is coherent with the results from Dakar and MotoGP injury analysis with a reduction of thoracic and collarbone fractures. In terms of perspective, if you look at on the top of the slide, you can see a timeline. This is just to show you the amount of data that we have and that we are recording every day. So in March 2022, we submitted the abstract for this conference. You can read on the title of our presentation, 60 million kilometers, more than 3,000 accidents. Today, October 22, we are here in Cologne, very nice city, cool people, and we are above 80 million kilometers, more than 4,500 accidents. And among these accidents, our product is able to detect 95% and inflate to protect the rider. And we estimate that in May 2023, we will reach 100 million kilometers, allowing us to improve even more our detection algorithm to increase the detection rate of the accident. Regarding the product itself, our objective is to reach a coverage rate close to 100% in 2023. We want also to create new detection modes and optimize protection areas because obviously the accident and the injuries are not the same regarding the practice that we perform with the motorcycle. Is not the same to ride on the road, on the track, or off-road, or enduro, motocross. There are many different disciplines, so we have to adapt our products to each user. And the final point is to quantify the effectiveness via real accident, because we have testimonies, we have a lot of data, we can do simulation, we can perform tests with dummies, but it's difficult to obtain detailed information about injuries and to compare our population to another one without airbag in order to estimate which is the real effectiveness of the device in terms of, for example, if we can reduce the length of a stay in a hospital, which kind of injuries we can avoid, we can mitigate, in which type of accidents, or there are still many questions to be answered. And we are going to start a cooperation with a research unit in order to try to answer all these questions. And just to give us another image of the data that we have, and maybe we could present it in the next EFZ in 2024. So if you regard the image on the picture on the top, we can see many points. Each point corresponds to one accident. That means that we are able to have the location of the rider when the accident occurs. And in the picture below, there are the distribution of the velocity at the instant of the accident. So this is not the testimony of the rider, not measured from the accident scene, but these are the measures from our technology, and we are able to estimate to measure the velocity at the instant of the accident, at the instant before the impact of the human body.
Thanks. And to finish, I guess there That's the very famous curve of diffusion of innovations. We are now at the phase of we just leave the 2.5% of people equipped. In France, we have altogether different airbag manufacturers, 5% of French motorcyclists. We in Emotion, we have something 1.3%. So we are now in the early adopter phase. So the diffusion of airbag should speed up, and there is 4 drivers to support this diffusion. The one is the proof of efficiency, and thanks to the jobs done by Pioneer presented before and the job we do at Emotion, it's more a scientific approach in parallel to the real data we have based on thousands of accidents. Then we need the standards, so there is still no standards on smart wearable airbags, and this is a work in progress that should be very soon done. We need also to work on the wide choice of product adapted to different users. Once again, it's nice to be protected, but if you want to feel cool and to enjoy riding your motorcycles. And the last point is availability and accessibility. So my last question would be that airbags will be the helmet of tomorrow. Thank you.
Thank you very much for a glimpse into the future. I see we have a question, please.
Good morning. My name is Kees Duivenstein. I'm from EU Darts. My colleagues provide training and service on analysis of data from event data recorders. And there's a link with the subject, suppose. You get a large amount of data about accidents and near accidents. A lot of contributions these days, like yesterday and today, make use of data from GIDAS and other sources. But your data could also be used for analysis and active safety. Do you have collaborations or requests from police forces or from researchers? And what's your opinion about that?
Yeah, the data is the raw materials of our use to understand the situation of accident as well even the use of the systems. We use the data to be sure that we trigger the airbag at the right time, and on the other side we avoid to trigger the airbags every other situation of normal riding. All the data are anonymous, so we use the data as a number. We never had, today, we didn't have so many inquiries of, let's say, a third party to understand more the use of it. Of course, we are here and working with pioneers in university to share the learnings we have, because we use our data to trigger on airbags. But if I take, for example, today, we have the data on every racetrack in Europe where our users are going, and I can tell you which racetrack are the more crashing ones versus the number of kilometers ridden on this particular racetrack. So that's the kind of thing we are computing, we are compiling, not directly useful for us, but potentially useful for someone else.
Please.
Yes. My name is Astrid Althoff. I'm die Motorradfrau. I'm a motorcycle trainer, safety trainer, and I've got a personal question. My first airbag, what I tested on my body, it was in 2012, 2014, I guess, in this direction, and I get killed a little bit because I'm a woman and I've got big breasts, and it was not nice at all. So my question, do you have some for female riders?
That's an excellent question, and yeah, the answer is yeah. In the picture I was showing you with the 40 different references, there is full, let's say, full female systems, and we shape the use of fabrics which are very elastic and able to adapt on the shape. And what you were just mentioning is key. Is whatever the airbag can save your life, you were not feeling comfortable or not feeling nice with it, you just remove it. So that's one of the main difference that moves narrow, and the chance that you have 9 brands with different fitting styles, different brands, logos, and use of materials that provide you something that should fit you.
One more, please.
Hello, good morning. My name is Jose Maria Riaño. I come from Ransdorf, from Spain. My question is, you are explaining us you have recorded a lot of data, but I wonder myself whether these users are, I guess, and you explain us, are heavy users, are people somehow very concerned. So I wonder if this is representative from the medium user, And the same kind of question with data recorded from MotoGP. I mean, those accidents are occurring in a very specific area, which are circuit tracks with not so many impacts as the real accidents on the streets and on the roads. So my question is how to get the precise or the right data to apply this to the real life riding. On the other hand, I wonder, I would like to question which, after having recorded all this data, which kind of accidents you think this protective equipment is more useful? Maybe urban use or non-urban use, or which models of accidents? Any conclusions on that? And my final question is regarding the homologation or the technical, the lack of the standards for electronic airbags. What should be done at that field? Well, that's all.
Thank you. The first thing is we used to say our users that they are part of the R&D team. It's like today, if you stand up on a motorcycle with an in-motion airbag system, you have the experience of 55,000 users in your back. So that's basically why people are quite open to share. And once again, if some of users say, I don't want to share my data, they can. In terms of representative of our systems, when we launch our technology, we have launched it in 2017, we have selected 500 users around Europe upon 10,000 people which was subscribing to try to get the most representative pictures of users. So just to give you a few facts, 85 million real data ridden on track, off-road, on-road, in Paris with scooters, in Brazil, in India. So we think, yes, that today we have probably one of the most extensive and kind of representative group of data. This data, once again, is coming in a big majority from Mr. X or Y from the use of motorcycle. MotoGP is just a small part, and I have to say that protecting MotoGP riders was kind of easy. Those guys race on 20, 22 racetrack a year. They go on their bike, they race, they stop, that's it. What happens when you have someone that drives with his wife and is driving a bit too fast and wife starts to eat his back? The complexity of smart wearable airbags is more on regular users. So we use MotoGP as let's say, a laboratory at the very beginning, but the main challenge to reach 100% coverage ratio versus 0 false triggering is on the real users. So I think we have already kind of extensive data, and we see it because we have less and less new situation we never feel before in last year versus 2 years ago. And give you an idea, the systems have been already into about 100 countries in the shoulders of, once again, 55,000 guys. Last point about the standards. There is already existing systems today to rank airbags from 0 to 5 star, which is the SRA, coming from the group of French insurance that give an idea about if you buy an airbag, is it a 1 on 5, 2 on 5, 5 on 5 airbag systems. And all the experts today, including Alpinestar, Dainese, InEmotion, are working as fast as we can to provide a CE standards, and the target is end of 23. Yeah.
Very quickly.
Yes, Merve from Bosch. Can you determine out of the data you get that in how many cases no e-call necessity would be given, so that the number of false positive calls for e-call can be reduced?
You mean e-call?
Yes.
Yeah, I think we are the only airbags that use e-call today. I think, honestly, I don't have the exact ratio in mind. Last time I checked, the figures was around below 10%. I mean, for 100 situation of crash, we deploy the airbags. The needs of rescue team was below 10%.
Thank you.
And I think I forgot one of your questions was, which are the type of accident the airbag protect? Honestly, that's the top one questions. My best dream is to come in the coming years in AFZ and say that how many days of hospital did InEmotion reduced? And that's the biggest question we have, we try to solve. I would say that We have a lot of users on racetrack, and we see that the people that crash sometimes they inflate the airbags 5-10 times a year without any injuries. And the only things we can say today is just based on the biomechanicians or the doctors that are right after the accident examining the body of the victims. And we got a lot of testimonies that says when they look to the bike, they look to the braking zones and stuff like this, they would expect much more injuries. And so I would say the use of airbags is good on urban, is good on rural, is good on racetrack. There is not, for the moment, a key usage or key applications. The next step for us, as Oscar was mentioning, is try to go more in detail into which particular case of accidents and mechanism of injuries airbags will reduce.
Thank you, gentlemen. We'll stop there. We'll need to get the last presentation in. Appreciate it. Our last two, yes, thank you. Last two presenters, we have Paul Mangen from Luxembourg. He's an engineer with the National Road Administration in Luxembourg, which is an organization for planning, building, and maintaining the highways and state roads. He has been deputy director since 2017 and holds an engineering degree from the University of Karlsruhe in Germany. Also sharing the podium is Martin Winkelbauer from Austria. He's a senior researcher for KFV, a nonprofit, non-governmental organization dealing with all aspects of road safety, home, sports, and leisure safety, as well as fire and property protection. The organization is highly interdisciplinary in research, lobbying, campaigning, consulting, and advocating. He's been doing research for 30 years in road safety and has been an expert witness since 2008. Interestingly, he does motorcycle security riding and bicycle racing. So please take it away.
Dankeschön, Ray, für die nette Einführung.
Thank you very much, Ray, for the kind introduction. We both will be speaking German. So let's start with the history of these road markings. And I'll give you some insight in the backgrounds, and then I will show you a lot of nice photos. We're based in Luxembourg, and Paul Mangen is going to talk about that. Well, all this started, the road markings, about more than 20 years ago, when the technician from Kärnten government watched car drivers, how they followed those fine white lines that the people applying the markings use as a model for marking afterwards. What can work for cars, of course, only works when you try to use it to give proper lines for motorcyclists in curves where you have problems with the trajectories and with the accidents when you leave the roads, and they happen because the riders try to avoid oncoming traffic and then fail, and they cannot finish their trajectory through the curve. So at the time, a green line was applied to the road, and if you believe it or not, the riders in this curve, that's quite a good curve, however, with many accidents, they followed this green line. And if you look at this today, and if you go on Google Street View, you see that this 20-year-old green line is still existing. And when you see the road markings that have been applied 7 years ago have faded and are hardly visible any longer. So then we continued. So the green lines would have been a nice idea, but not really the model that you can apply everywhere. So we used another fact, the fact that riders worldwide are being taught that you should not go across those lines, especially when it's wet. And the markings that we use to provide a lot more grip than the tarmac around. But don't tell anybody about that. So now the first test were those W-shaped markings, and that was quite successful because the riders avoided the markets, and they were at a sufficient distance from the oncoming traffic, and the accidents disappeared as soon as the markings had been applied. And Of course, we saw this several times, but at some point in time, we had to research this in a scientific way. But in the meantime, in Slovenia, they thought they have to try this out, and they tried this on the Leibacher race course. And this is slightly south of Ljubljana. That's where they applied these markings. And the motorcycle, the rider associations, they said they can't do this, and they disagreed. But they found that with these markings, let's say the unofficial road races, and that the race is only won by those who can really ride a bike properly. And I said, okay, we have to do this research in a scientific way. We applied road markings at 9 curves, and we found something different than the W-shaped markings. And we used these elliptic designs, and in Lower Austria we wanted the bar designs. We tried out both, and as you see in green and red, that both with elliptic design and the bar design, we improved the lines that the riders took. Then there was a special case, the Großglockner road in the high Alps, and we have a special commitment and responsibility there for avoiding accidents. And for safety, road safety, and they asked me to apply markings there, so everything can be done, has been done to avoid motorbike accidents. In Styria, we learned that you can plan those markings also, but that they do not survive when you have a lot of lorry traffic there. Then Tyrol in 2019, the land government gave me 25,000 and it said, do something that will avoid rider accidents. We looked for dangerous curves, bends, and we looked for road markings, and with the help of our electronic tool, we defined and looked for the dangerous bends and curves, and then we applied these road markings. Now the Tulbinger Kugel, that is one of the race courses of the Jena riders, and that's you do 10 laps in the morning, 10 the other way around, and you hear those riders 3 kilometers. And that means that people living there are not really enjoying that. And it said there was a safety problem in 3 curves. They wanted to have markings applied on some more curves, and the feedback was the people living there didn't complain any longer. And there are no more injuries, and the fire brigade liked the fact that they didn't have to retrieve bikes from the forest. There are fewer bikes, people don't stay that long, and all that costs 3,000 euros. And the mayor said that was worth every cent. Then we evaluated this, what we had done in 2017 and 2020, and big surprise that the elliptic design has improved, and the bar design has caught up, so that we can say now that they are both efficient. And also, this sounds funny that you need enough accidents to work this out. So from 16 to 7 crashes is a great success, but not significant. Now we continued in Tyrol. We had 19 curves, and before we applied the markings, we had about 6 slight injuries and 6 severe injuries and 0.57 fatalities per year. And afterwards, although there was less traffic due to the pandemic, so there was not a reduction. We had 80% fewer crashes and injuries, but still not a real reduction, because the research is cannibalizing itself, because we reduced the accidents that we didn't get any significant values. But at some point in time, in between, we also exported the road markings to Luxembourg and And Mr. Mangen is going to tell you that story now. Well, hello, Paul Mangen. So, okay, now in Luxembourg, this is the first slide that I show you. We have rather bad statistics with fatal accidents. So we have a very good tendency in terms of general fatal accidents, but however, in fatal accidents, they have remained constant from 1993, and unfortunately, it has not improved in 2022. So the reason for that is Luxembourg has a lot of people who commute, and a lot of commuters ride a bike, and they all go to Luxembourg City, and that's what you see in blue now. And then we have a great, very large rural regions at the south of Germany, the Luxembourg Ardennes, and that's mainly tourists that are using it, and we cannot reach tourists. We tried to do this with sensitization, but these touristic routes are very dangerous because they contain a lot of bends and curves. So now if you compare this with the figures from 2016-2021, at the bottom we have the commuters and the tourists on top. So now we carried out a study, and we asked, what do we do with this study? Because we checked road safety, and we found that the N25 between Wils and Kautenberg, that contains many bends, that the top speed was 166 kilometers, and the V85, that is 85% of the people are running at 103. There's a high number of motorcycle accidents that we didn't know, and from other studies on road safety. So we had mainly foreigners, and at weekends in good weather conditions. And then we took a look at this from 2013 to 2017, and when the accidents happened, that was at the weekend, which is atypical for all the other roads that we had investigated. And so we tried to find out what we could do. And then we had the idea, or the Austrian had this idea to use these special markings, and so we said we have many bends that follow, and with the information on from Austria, we use this as a basis what is possible according to our regulations in Luxembourg. So we couldn't buy these bars in Luxembourg, and that was too much short notice. So we divided the bends in 3 zones. The red you shouldn't use. Orange is where you're still in the oncoming traffic with your head, and the green one is where you're outside the danger zone. So then we applied these markings, and we tested this with the police in Luxembourg until it worked. And you see on the right-hand side, you see a sequence of bends where it's not the left bend, but it's the right one, and then you have a left bend, and if you approach this in the wrong way, you don't manage to get through this. And those are the markings that we applied all along that road. Then we had some signposting put there, and there are also and all the roads that are being frequently used by riders, and we had this special marking there, the security markings. Then we took a scientific approach. We used one section where we installed 3 cameras. This is where you see those cameras, the camera positions, and we positioned the cameras in such a way that we counted this at the weekend before the markings were applied, and we did so on the 23rd and 24th of June 2018, and what the riding behavior was. And then we followed this up at the second weekend, so this week after the marking were applied, then 3 weeks after, and then again 2 months later. So that took us to the end of August. to find out whether this was having a sustainable effect also through the summer. So on the left, you see the before, that is 10% of the riders that we counted covered the road in the green area, 80% in yellow and 10 in the red. And then we applied the marking that you see the dotted black line, and then we had an increase from 10% to 60% in green. So then we gave out only little information apart from the signposting. Only the motorcycle associations knew this, and the Road Safety Ministry knew about this, but we didn't advertise it. So we wanted to test this, how intuitive this was. And the police said that it's not the optimal line that you follow, but it is a safe one. So we tested this, and that lasted and repeated over the months. So the red area was reduced by 1 or 2%. This is very, very good. The yellow area stabilized at 40% and the green at 60%. That didn't have any impact on other road users. This is neither the bicycle riders nor the cars and tractors and lorries. They don't use that very frequently, but that didn't impact on those. And that didn't have any impact on the way they're using that road. And the riders you see, one here in the middle is really on the wrong path, but it is being understood by the riders, basically. And now what I said right at the beginning, it is the northern region of Luxembourg where this makes sense. And in the years following that, we applied marking in 2019, 2020, 2021, and in the south we wanted to do so, but the road is too narrow to apply these markings. So there are a lot of small technical criteria that you have to know to be successful. So there's 2021 we did cover the second route in the north. And here in 2019 it shows that we did a retroactive analysis, and you see that at the first weekend it was 33%, and the week after it was 49%, and also the red area reduced almost to 0. For the time being, we have about 50 curves or bends on the 5 routes that you see and that have been equipped with these road markings, and we only had 1 accident with a motorbike, and that was in a right-hand turn and not in a left-hand turn. So now, if you want to look at this, of course we have a PowerPoint show where you can that you can call up, and the German police visited in 2020, and they produced a video with drones, and you can follow the motorcycle and with the G Pro camera. And you can take a look at that on this website. And I think you get in the presentations later on with all these links, and that has been used as a report for the Traffic Technical Journal, and also in Switzerland they have started to apply these road markings. That's what I wanted to show you, the road markings in Luxembourg. Thank you very much for your attention.
Thank you. Quite fascinating. We've got maybe 2 minutes for questions. Yes, please.
Well, I had the pleasure to follow an event at the German Luxembourg Police Control, and then policemen from 4 countries were taken on board. There was one from Belgium, from Holland, and the Luxembourg policemen. They demonstrated the system, and the colleagues from the other countries that didn't know this were very impressed. And I tried it out myself. The grip is good, and also when in wet conditions, the grip is good. And you said that we exported that from Austria to Luxembourg, then to Switzerland. What about the other European countries, if you're right? So the Black Forest, for instance, that riders approach the bends in the wrong manner. It's a big problem. Well, let's say, and I cannot answer for Austria, but for Luxembourg, the advantage is that we have in our road safety regulations, we can decide on the markings ourselves. But I know that in Germany, you have to have studies, you have to adjust the regulations. That's what we heard from the police, from Rheinland Appellate, when they came to visit us. Well, you would have to turn to the German institutes and the ministries. I don't know what the legal requirements are in Germany in order to apply such markings. And I have to say also that when you enter towns, we have similar markings to reduce the speed. And that's what people know in Luxembourg. So that was nothing really new. The regulations in Luxembourg don't say anything. They just say you can play bars. Whether this is if you have to stop at traffic lights, it's possible. But they have no further details. And I think in Germany it's much more complicated because everything has to be detailed to a very high extent.
One more, please, real quick.
Rolf Rieling from the Biker Union.
Rolf Rieling from the Biker Union in Germany. Just to add something to it, in Germany it's extremely difficult because the road regulations do not allow for such markings. And we have a pilot project that is being prepared at the moment. But for this, you had to change some regulations, and which have been made now by surveying or questioning the Länder in Germany, which have their own opinion. And I assume that we have a chance that at the end of the year, beginning of the next year, we will have a pilot road marking course in Aachen. Well, Luxembourg is we don't have that many long roads. That's our advantage.
We best move on. Thank you very much. If you have further questions, please seek out presenters in the panel. Let's give them one more thank you. And with that, we'll move into our coffee break.
That's why we should continue right away. I have the pleasure to be the host of the next chair of the next session and introduce the next speaker, Nora Merkel. She is from the Würzburg Institute for Traffic Sciences at WGmbH, Germany. I know her for some time through her activities at the Technical University in Darmstadt in 2022. Oh, it's just very recent. Congratulations to the promotion. She has quite a doctoral degree through autonomous motion braking for motorcycles, and her subject now is the safety potential of data glasses for motorcyclists. So very, very excited to hear your talk, Mrs. Merkel.
Vielen Dank, Herr Otte, für die Einleitung.
Thanks, Mr. Otte, for the kind words of introduction.
I'd like to talk about the safety potential.
Ich möchte heute vom Sicherheitspotenzial.
Which was a study that we conducted on behalf of BMW Motorrad at WVW. And after giving a short introduction to the idea of the investigations, I'd like to talk about the two main parts of the work, which was on the one hand the development of an investigation method, and on the other hand, of course, the results of the study. And in the end, of course, we'll sum things up. So what was the actual idea of our work? From accident data, we know that lots of accidents happen because riders are distracted from what they are actually doing. And besides distraction because of things in the surroundings, this can also be caused by, for example, looking onto the dashboard for retrieving information like the actual gear or something. And solutions we know for such cases in passenger cars are so-called head-up displays that project information into the windscreen so that the driver does not have to look into the dashboard. And what we asked ourselves is, are there comparable solutions that we can use for motorcycles? As you all know, typically we do not have windscreens, at least not in all sorts of motorcycles. And one possible other technology could be so-called data glasses. These are glasses that you can wear under your helmet, and information can be projected into your natural line of sight. And what we now did was, on the one hand, we worked on the question, do these data glasses have the possibility to increase safety for motorcyclists? And on the other hand, the question, how can we investigate this safety potential? So we needed some kind of investigation method. For the two research questions, what is the potential safety benefit of using data glasses on a motorcycle? And on the other hand, can this technology be used safely? What is to say, is it possible that the use of data glasses causes new risks? We have to be sure about this before we can actually use them. From the field of passenger cars, we know a lot of established investigation standards as the development of passenger car assistance systems are some years ahead. They have a lot more established standards there. And as we have some differences between motorcycles and cars, as we all know, we cannot adapt these standards or methods directly, as we have a slightly more complex riding task, and for example other differences on the geometry of the vehicle. For example, we have often larger dashboard downward angles, so the head or eye movements riders have to make to retrieve information from their dashboard is often higher than in passenger cars. So what we did, we started with a theory of resource models that says that riders have a limited amount of resources, and if we add any kind of secondary task to the riding task, a part of the resources is taken from the riding task. And in order to complete our riding task safely, we should not exceed the resource limit the rider has. And retrieving information from a vehicle's dashboard can be regarded as such a secondary task that is competing for resources the rider actually needs for the riding task. So a secondary task should always be designed in a way that demands minimal workload in order to keep riding as safe as possible. What we now did for our investigations on data classes, we combined 3 methods known from the passenger car section, and I'll explain on these methods on the next slides. First of all, we have the ISO lane change test, ISO 26022, which is a so-called dual task method, which investigates the influence of a secondary task on the primary driving, or in our case, riding task. The primary task is a lane change task. The rider has to perform lane changes according to signs that are placed next to the street, and it's always the same setup. A lane change sign appears at a time to arrival of 2.4 seconds. Then the rider has 600 milliseconds to react to the sign, and what means he has to recognize it, understand, and then there are another 600 milliseconds for the actual lane change. And after the rider has passed the sign, there is a section of straight riding again until the next sign turns up. For the motorcycle test case, we made some adaptations. In the ISO standard, the experiment velocity usually is 60 kilometers per hour. We increased it a bit. As I said before, we have a more complex riding task on a motorcycle, as we have to stabilize the vehicle. And in order to use the self-stabilizing effect of the motorcycle, we increased the experiment's velocity in order to keep the riding task at a decent level. We adapted the ISO test sections so to keep the times I explained before, the 2.5 seconds for time to arrival when the sign turns up and so on. So the sections on the test track became a bit longer to keep the reaction times constant. We have the secondary task in a lane change test. In our case, we installed a reaction task with a turn-by-turn indications that turned up in the dashboard or the data classes, depending on the condition. And we compared reaction times and the success of the riders to react to the upturning indications. They did not have to react to what the indication actually showed. They only had to react by pressing a button at the time the indication changed. In the end, we had 4 experiment conditions, 1 baseline task in which the riders only had to perform the lane change test, then the dashboard condition where the secondary task was performed on the standard dashboard, then the conditions where the riders wore data classes, and 1 test condition in which both display technologies were used at the same time, displaying the same information. In order to investigate the workload that was added to the riders by the secondary task, we combined the lane change test with the so-called detection response task, which is also retrieved from an ISO standard. Here we have stimuli that pop up in the peripheral field of view, and the rider has to react every time such a stimulus turns up. We had 5 positions in the field of view where those stimuli could turn up. Of course, only 1 at a time, and they occurred at those positions randomly. The rider has to react by pushing a button, and the success of detection and also the reaction times were evaluated. An additional investigation on the workload we did was the evaluation of the subjectively experienced workload, which was done by the NASA task load index. This is a subjective evaluation on 6 different subscales, which you can see here, and which was done by a questionnaire. So we come to the application of the method, where we did the study on our dynamic motorcycle simulator that we already saw yesterday in Sebastian's presentation. And we designed a test course which contained 3 blocks of 18 lane changes each for each test condition. So riders had 54 lane changes on each condition. One of these blocks took about 3 minutes, and the first blocks were performed without the detection response task, which was then added on the last block of lane changes. What we can see in the lower right corner is the kind of signs the participants saw to indicate the next lane change. Here we see a sign that indicates a lane change to the left lane. The number of lane changes from left to right and also of single or double lane changes were balanced in the test track. And yeah, then we invited our participants. They, after being welcomed at our institute and all the paperwork, they had the chance to familiarize with the simulator and practice the tasks, first isolatedly, then the combined tasks. And after that, we did the actual measurements with a short break and questionnaire after each condition. And in the end, there was also a final inquiry where they had to evaluate what they experienced. We conducted the study with 24 participants. We have a participant panel at WVV with trained participants who are familiar with the simulator, and we try to cover a wide range of different ages and riding experience with the test panel. How did we evaluate the results? First of all, the lane change test. The success in the riding task was, on the one hand, evaluated by the deviation of reference trajectory. The reference path was calculated based on the so-called basis model according to the ISO standard, which is more or less a average deviation over the whole test track. That was calculated for each rider, as well as the evaluation of the success in lane changes, which means that we evaluated if the rider succeeded in reaching the correct lane within the displayed sign when before they actually passed the lane change sign. When we now look at the results of those lane changes, we can see that there are slightly higher deviations in the conditions with the secondary task compared to the baseline, which we see in blue on the left side of the graph. But yeah, it's quite small difference. And when we look at the success of the lane changes, we see that we have a very, very low number of lane changes where the riders did not succeed, which are all lower than 1%. So we can say we have an influence of the secondary tasks on the riding task, but we cannot really see differences between the different conditions or different display technologies. Where we actually can find differences is in the reaction times of the secondary task. So how long did it take the riders to react to the changing turn-by-turn indications? On the left side we see the distribution of reaction times for the dashboard conditions or for the standard condition. And what we can see is that by using the data classes in the two right diagrams, we can reduce reaction times significantly. So while we have a mean reaction time for the dashboard of 2.5 seconds, we are below 2 seconds for the other conditions. We also have a reduced number of missed indications for the data classes condition, and yeah, which is below 2%, while it is at 6.5% for the dashboard condition. We can also see effects of the secondary task in the workload evaluation in the detection response task, where we can see that all secondary task conditions let the reaction times for the DRT increase, while we have slightly better reaction times at the outer positions of the stimuli for the data classes. The secondary task also increases the number of missings during the detection response task, which we can see in the table at the right. In the workload assessment of the subjectively experienced workload, we can see that the workload slightly increases for all secondary task conditions, but it's only significant we have a significant difference between the standard dashboard condition and the data classes condition in two of the sub-scales, which are the mental and the temporal load the participants experience. So here we have a measurable difference between the standard dashboard condition and the data classes condition. So to sum up the results, the secondary task in general has an influence on the riding task, but there is no significant difference between the different display technologies. While we can see a difference in the reaction times are reduced by use of the data classes, which is probably because riders do not have to do so large head or eye movements to retrieve information from their display technology. The workload is also influenced by the secondary task, and the recognition of stimuli in the peripheral positions is slightly faster with the data classes. Again, because gazes away from the forward road scene are less when we use the data classes. And the detection response task results are confirmed by the subjectively experienced workload. What we can say about the investigation method is that we adapted methods from the passenger car sector for motorcycles, and they were applied in a simulator study. The method proved to be applicable. We received plausible results showing the differences, and also some results that were same for the different display technologies. And what we can conclude is that the successful implementation of the method could be a basis for future investigations, as it is based on well-established standards from the passenger car sector, and the possibility to evaluate such technologies on the simulator could also be an advantage for future investigations, as it is in a safe environment with a relatively low effort compared to real-world riding studies. Thank you.
Thank you, Mrs. Merkel. Are there questions? Please go to the microphone, and if not, I would like to ask, how is the reality for such device in practice? Because I remember at the last conference we had also a presentation about the glasses. You made a good presentation about this and find a good benefit for this. For me, there are one major question also besides this: how is the situation comparing your simulation work with the practice orientation? Because in practice we have some influence from the light, from the few observations of the different drivers and so on. Can you say something about the reality?
Well, on the first question, we can say that the data classes we used are commercially available, so the technology itself is already there, and we also know applications of such head-up display solutions for motorcycle that are already available. And on the second question, of course, we have kind of laboratory conditions on the simulator, but I think the technical realization is the contrast high enough was not the focus of our investigation. So our investigations were really on how does the rider interact with the technology. So this technical point is another investigation that manufacturers have to make, of course.
Which we need.
Yeah,
before
definitely.
Implemented.
Yeah.
Okay, no further questions. Then thank you very much.
Thank you.
So we are coming to the next presenter, Simon McCool from the University of Hertfordshire. I hope that was right. Yes, United Kingdom. He is researcher in computer vision and machine learning, teacher and lecturer, and technical consultant. His presentation is Mitigation Motorcycle Accidents at Yield Junctions using Computer Visions and Deep Learning.
Okay, thank you.
It's your task.
Thank you for the introduction. It's a pleasure to present my work. I need all the opportunities I can get because it's a field that is always changing and always adapting, so we can't stand still. So any input from any of you would be most welcome. I am a PhD student, despite my grey hair. That is something I got into because of motorcycling, and that'll become apparent as we go through the presentation. But my work with computers has been with 40 years or so, and motorcycling also for 40 years or so. So combining them both to get a PhD is a bit of a dream for me. So I'll give you a brief overview of what I aim to present, and then go into a little bit more detail. My usual audience is computer scientists, so forgive me if I go into any esoteric discussion about deep learning and so on. I have tried to make it accessible to everybody, but forgive me if that hasn't really worked. So I'll go into the research aim and motivation behind that. I researched into the causality. I mean, I really don't have to go into any more detail than just to summarize, because listening here for the last day and a half, it's clear there is a lot of evidence into what's happening at junctions. That's my focus, and on the road to motorcyclists. However, it does play a major part in my work, because the behavior of drivers leads into my data sets, and the data sets are used to train my algorithms, and so it is of prime importance. The research questions that have been raised are continual. As I say, this field is changing consistently with the increase in computer technology, and the more powerful the computers, the more they can do, therefore the boundaries will be pushed. I'll also go into the methods, and then we can have a look at some results on synthetic data. It took a while to get ethical approval from the university because of the data protection laws on capturing identification numbers of cars and people's faces and so on. So my preliminary work is on synthetic data, although I now have ethic approval and I am building a live database. So my aim is to exploit camera data, 2D camera data, nothing technologically advanced, because it has to fit onto a motorcycle. And capturing that data is relatively easy with a dash cam on a motorcycle. However, I want to drill down into the data and pick out pixel vectors. Basically, I want to be able to analyze pixel movement, vector parameters such as velocity, distance, acceleration, and also from a point of view, an outcome as I say, my work is focused on junctions. These are junctions in the UK, but they'll translate to junctions anywhere in the world. And the outcome of the junction is the most important part. What led up to that outcome at the junction? Did the driver stop? And what does that look like from pixel data? Did the driver not stop and carry on over the junction into oncoming traffic? What did that look like? And that's what I'm looking at now. And really, what that's going to lead to is a prediction of what a vehicle will do as it's approaching the junction. In other words, increase that reaction time for the motorcyclist and hopefully give them a fraction, a window more than they may have had in the past. Excuse me. Oh. That wasn't me. I don't know what happened there. So the main objective is to predict driver intent. Driver can be a driver of another motorcycle, a car, a truck, anything that's approaching the junction and coming out. I've described why, and I have been working on two main methods. So one is a classification framework where it's trained on the feature vectors that I mentioned, and the classification framework is a deep learning framework that is trained on as much data, an endless supply of data is required, as much data as possible in order to predict an accurate outcome. And the other one will be, it's an algorithm written to interpret the pixel data live. So from the camera on board the motorcycle, this data will be analyzed in real time and a prediction will be given within milliseconds. That's the goal. And the more accurate the classifier is, based on the amount of data I have, the more accurate the live prediction will become. So it is a cyclical thing, and one feeds the other, so to speak. Motivation? Well, I really don't have to go into too much detail. As I mentioned earlier, my usual audience is computer scientists, and this is the part when I discuss the application of deep learning. They ask lots of questions and they're very interested, and I'm sure all of you are also, but I really don't want to beat that drum too much. But clearly there is a need for some kind of help at unsignalized junctions because the amount of accidents there in the UK, it's quite horrific. I think there's up to 300 people a year killed on these types of junctions alone, regardless of any other application. So here's some video clip that I just used as an example. So in my 40 years of driving motorcycles, and I ride every day, that's my only mode of transport, I do see this quite a lot in the UK. Not as dramatic as that. That is probably a more dramatic, but certainly a near miss happens probably once every 2 weeks. So what can I do about that? Well, this is a quick experiment. Sorry about the size, but the algorithm that this gets fed into is quite hungry. Can you see okay? So we're now actually seeing a trigger to say that the vehicle was coming. So what's causing this? And there's lots of reasons. And I said earlier on that the psychological reasoning behind a lot of this really feeds into my work a lot. And I need to know why, because any driver trait and any behavior trait that I can use to feed my classifier, to create a data set, to train my classifier further is only going to benefit, because the more input I can have, the higher the accuracy. And with engineering and hyperparameter training, I can then increase the inference rate. In other words, the performance, the speed of the reaction and the speed of the actual prediction. So a lot of studies have looked at reasoning behind this, and I spoke to Peter Chapman of Nottingham University, and he has written quite a few papers, I've referenced these, on the causality of motorcycle accident at junctions. And he's really concluded that it's older drivers, and they literally just don't see the motorcyclist. You know, there's no deliberate action. Sometimes there's just impatience, but most of it is down to driver error, as we all know. And these studies that I've read really say that driver education is one of the main solutions. However, we can actually take a stand at this and maybe use technology to assist. And there is technology out there. We've heard, I think Cosmo, he discussed motorcycle automatic emergency braking plus other systems, which are invaluable, absolutely necessary. And if we can get the stabilization perfect, they are great solutions. However, these solutions react when the obstacle or the offending vehicle is already in front of the motorcycle. So the car's already pulled out, basically. And the reaction time is all dependent on the distance to impact. Whereas I'm proposing that maybe we could extend that with an intent prediction based on the methods I mentioned. And that really is the foundation of my work. The foundation of the work is to increase that time between rider and impact. So I also mentioned that a lot of research questions popped up. I mean, these are only there just to show you the way that this develops, because as you try and improve one part of a system, further questioning comes up. And it seems that it's much, much bigger than just detecting a vehicle. There's a lot behind the scenes, and I have further questions, but I've narrowed those down now. I'm actually at a further stage at this and narrowed it down to two main questions, and those questions will be met with these methods. So the methods combined together, although they're separate methods, they're both fed from observations from traffic, and initially it was from simulated traffic, and now it's going to be from live video feed from a motorcycle driving in the streets as normal, with the camera slightly pointing towards the inside. And there's two methods. I've named these methods because we were getting confused on which method was which, DAISY and Duke. DAISY is the linear classifier that I mentioned, which will produce an outcome based on the feature vector inputs. So the outcome will be stop or not stop based on those inputs. And Duke is the real-time algorithm. Duke is the one that will actually work on the motorcycle and give a live prediction. And that is constantly updated with the findings from DAISY. And the more data DAISY gets, the more patterns that the deep learning classifier can find. The more patterns it can find, the more accurate the outcomes. So the classifier itself, I mean, this diagram really doesn't say much other than it's a neural network, and the neural network works in a very similar way to a human brain. And the inputs on the left there, SMP 1 to 4, that's the inputs I mentioned on velocity, acceleration, distance, and then SMP 4 would be an outcome. So when we train this classifier, we train it based on the fact that there was an outcome at a junction. So a vehicle was approaching, and we take all the parameters we can, all the dynamic profile of that vehicle, and then we say what happened. Okay, it came to a stop. It didn't come to a stop. And then we classify that behavior as one of those two outcomes. And that there builds our data set. And then we feed a deep learning algorithm all that data to look for patterns, to see if we can isolate a typical junction approach that would give us the idea that this vehicle is going to come straight at us or across the line. And that's the goal, that's the end game. So that's the classification. The live prediction comes from a number of components. And the components are chosen because they need to be fast. The inference rate has to be very quick. So what this does is it classifies the vehicle, first of all, as a vehicle. And then it's being tracked. So it's tracked from frame to frame in the video. And that tracking allows us to differentiate between a vehicle moving away or moving towards us. As I say, my work is on junctions, so I'm interested in the UK. I'm interested in vehicles coming from the left-hand side and coming towards the car almost perpendicular within a range of some degrees. And the algorithm that's used for that is YOLO, and the tracking algorithm is deep sort. These are already available. I've combined those together with another algorithm that I wrote myself that will actually take out that pixel data. And that's the pixel data that's then analyzed. And within that algorithm, there's a time feature which can actually say what the vehicle was doing t-1, and then allow a prediction to be made based on not only the classification from DAISY, but also the behavior of the vehicle in real time. That's all done with bounding boxes, and a bounding box is drawn around. You've probably seen object detection applications. I'm more interested in the features of the center of the box, and the center of the box is where I can pick the dynamic movement. Now, both of these methods are put together with a framework. And as I alluded to earlier on, the framework is perpetuating. So essentially what happens is we get 2D video feed as much as possible, and that is fed through into Duke, which will analyze that data and determine whether or not the vehicle has crossed the line, and then classify that. That's then fed into the data set for training in DAISY, and then at the end of this, if you look at 3 and 4, you have two outcomes. You have a prediction based on live data and a prediction based on classification. And that framework is, although there's quite a lot of parts there, it should be able to predict within milliseconds, rather than it looks quite cumbersome in that image. I've never seen it so big, so that's probably why. I mentioned about inference rate. We have to have a fast inference rate. We do have to have performance. In that order, you have to tune the data set. So you don't want to be classifying and tracking objects that have no interest to you. And the way to do that is to filter out and retrain the data set to look at target objects. And this example here shows vehicles from the angle that you would expect them to be viewed as you approach the junction. So it's going to be from sideways, from the right-hand side of the vehicle around to almost the front of the vehicle. And a host of vehicles have been used in that training. And those vehicles mean that any car that's going away from the junction or has gone into the junction is driving down the road, for example, the rear of the vehicle is not classified, which would take up valuable computing power. It would take up computational load, and that would mean that it would slow the system down. So this way, we focus the data set just on those vehicles. So it's essentially a very specific use of this technology, and it seems to have improved performance not so much accuracy, but performance quite a lot. So we have some results in the confusion matrix, and this is on simulated data, and the results are quite promising from that point of view. As I say, we're building the data set up daily, and there is more data being added, more scenarios being added. There can't be an infinite number of scenarios, but certainly we need plenty more. And it shows that maybe it's an 89% accuracy. But then you would say that 11% of the time you're missing a classification. So when it becomes black and white like that, it's not so good. So work to be done there. And from Duke, we are looking at real-time classification. Not as good, but it did have 4 parameters to look at, which were merge yield, slow, no stop, no slow and no yield. In other words, behavior to a junction, as the vehicle comes to the junction, it slows and then carries on. Or it slows and then carries on over the junction, or it goes to the junction quite quickly. It looks like it's going to just carry on, but it stops. So there's quite a lot of parameters there to be analysed. A visual representation of the results. So the number is the vehicle identity for tracking. So number 10, number 1, as soon as a vehicle becomes of interest, it gets a tracking identification number, and that's what those numbers are. So at the top there, Duke thought that this vehicle was going to yield, and actually it did yield. And at the bottom, the vehicle was approaching the junction. The algorithm thought it wasn't going to yield, and it didn't yield. It carried on. So I mentioned the fact that we need to build the data set up, and the data set is being built. This is an example of a junction it's not far from London, about 15, 20 miles. And it's a typical junction. It's got all the road users, cyclists, cars, trucks, and so on. And the video camera will be sitting there absorbing what's going on. I've given some views from above and to the side and so on, just to give you an idea. And we look at as many junctions as possible and with as much data as possible. Oh, I think that was a visual cue for me. Essentially, that data will be fed into DAISY for training, and that will give us, that's a very fast junction. There are tighter urban junctions, which are square to the road, that we'll be looking at also. So really, it's in summary, it's more of it's a feasibility study. It was more to do with the fact that all of that can be put together as a feasibility study. And looking at it, it's grown some long legs now. As I say, we're building the data set in order to increase the accuracy of the classification. And one of the things that Peter Chapman mentioned was the fact that he noticed in all his experimentation there was hesitation before a junction. Hesitation at the junction, and that's a trait that can be analysed through acceleration profiles. So the next steps, live data. It will be essentially on UK roads to start with, and it will be the DAISY and Duke will put in a single framework, which will be self-perpetuating and working on their own and producing results without any input from a human being, essentially. So that, some references there, that is it. Thank you so much.
Yes, Simon, sorry that I have to interrupt you and to remind you to the time. Is there one quick question? Yes, please, shortly.
Hi, Marilyn Nugent from University of Florence. So from what I understand, you're using these data at different intersections to predict behavior of drivers and possibly making mistakes that cause conflict situations. I'm wondering, can this similar approach be used to take a more systems approach and look at what is it about the different intersections that are affording certain types of behavior that could end in risky situations?
Yes, that's a very good question. This is part of the reason I've linked up or started to link up with Peter Chapman from Nottingham. His work is on the psychological side of driving, and he looks at junction, basically the junction schematic, and he looks at drivers in detail. I think for my study, it's much more of a computer science study, but I would say that there's a strong link from that to the different types of junctions and the use of the junctions. And it needs to combine all road users into one solution, so to speak. My work is very focused on motorcycles and cars because cars predominantly are the culprits when it comes to junction accidents. But yes, I can see there's a strong link.
Thank you.
Thanks.
Thank you very much.
Okay, thank you.
So we are coming to the next presenter, Thierry Scherer. He comes from the University Gustav Eiffel Laboratory of Accident Mechanism and Analysis, and Thierry is a doctor engineer and senior researcher at IFSTAR since 1998. He worked 12 years at the Laboratory of Biomechanics and is now Deputy Director of Laboratory of Accident Mechanism and Analysis. So I think our work is similar, the same in biomechanics.
Yes.
And we know each other from CEN standardization of Working Group 9 protective clothing. Thank you very much.
Thank you, Chairman Dietmar. So today my topics will be motorcyclist real use of vehicle dynamics, and I have performed this work with my colleagues Claire Nod and Christophe Perrin from the Laboratory of Accident Mechanisms Analysis. The context is, you know it very well. So the motorcyclist represents less part of the traffic on the roads, but represents a big percentage of road fatalities. And so the idea is to develop lots of knowledge concerning their behavior. And here the approach is to consider the naturalistic driving studies to develop knowledge on their behavior. Naturalistic driving studies are rare for motorcyclists, and so this is one of the originality of this work. The objective was to update the use of motorcycle dynamics capacities in terms of how the motorcyclists drive or ride. The objective is to assess the relevance of data recorded by event data recorder embedded on the vehicles in order to know the average and extreme stress levels practiced, like, for example, speed, accelerations, rotation rates, and so on. And the idea is to evaluate the riding behavior of different persons individually, and to compare the riding profiles of motorcyclists in order to know who asks to the vehicle lots of solicitation and who asks less solicitation. And also the idea is to identify road infrastructure incidents and what could be the interaction with other road users. Material and methods. This work is based on 26 motorcycle of volunteers. And in fact, we have put event data recorder on these 26 motorcycles, and the event data recorder is a mobile phone with a small camera, as you can see here. So it's endoscopic camera, very small, and a very discrete camera on the front of a bicycle. And the mobile phone is placed under the seat of a motorbike. We have recorded these 26 volunteers during 1 year and a half. And the motorcyclists come from 3 regions of France, one in the north, near to Rouen, and 2 in the south of France, one near to Montpellier, and the other one in Salon and Marseille. And of course, to do this research, we have obtained all the ethical approval, and in particular, data privacy. Concerning material and methods, we have recording, in particular, aggregate data analysis, which is a distribution of accelerations and rotation rates, like the yaw, the roar, and the pitch angular velocities and the speeds. So on the right side, on the top of the slide, you can see graphs which cross the acceleration. So in the y-axis you have the acceleration of a motorbike, and here it's braking. And on the x-axis you have the angular velocity on left turn and right turn. And when the motorbike reach one of the solicitation, this matrix is colored by red, and so it gives us information about what is the use of the dynamics of a motorbike by the users. And on the graphs on the bottom, we had another information like the time spent on the duration, and the duration spent on one of the solicitation, and the color here, it's the color of the speed. And of course, as you have a red color, it's higher speed. And we have calculated some indicators concerning the different behavior of motorcyclists. Results. The first results concern the general overview of what we have obtained. And in this, during 1 year and a half, we obtained about 6,500 trips, which represent more than 80,000 of kilometers. And when in average, it represents 250 trips per motorcyclist, and more than 3,000 distance of kilometers. On the bottom, you have a different map of trips in the different regions. Results concerning the speed. So here you have the different histogram of the speed reached by the different motorcyclists. And what we can see is, for example, that 22% of the time of the motorcyclists is a standstill or very low speeds, but also 80% of the time is under 19 kilometers per hour. And we have observed also some exit speed, 3.2% of the time, more than 130 kilometers per hour, and sometimes, very rare, very high speed, because more than 150 kilometers per hour. And based on this graph, which is the average behavior of a motorcyclist, it's possible to define what is the smoothest behavior and what is the sportiest behavior. So here, for example, you have the blue one is the average, as I just said before. And in green, you have the smoothest behavior of a motorcyclist, a volunteer. But in red, you have also the sportiest, and as you can see, of course, the sportiest reach more high speed, more than 100 kilometers per hour. Results concerning acceleration. So here you have the graphs of acceleration reached by the different volunteers. Of course, lots of acceleration are near to 0 meter per second square. But what it is interesting is to see that 8.5% of the time is between -2 and -1 meter per second square, so smooth braking. And we have observed also hard braking, 0.2% of the time. And when we compare this value with, for example, cars, we have observed that it's more than cars. Concerning acceleration, positive acceleration, we have 3.2% of the time more than 130 kilometers per hour. I showed you it before. And for lateral acceleration, so we have very few acceleration more than 1 meter per second square, but it's normal because the car compensates the lateral acceleration on the curves due to the roll angle that it takes. So it's normal that we don't have lateral acceleration compared to the cars. And for vertical acceleration, it's very linked to road layout like speed bumps and railroad tracks and manholes and so on. Concerning angular velocities, so you have very high pitch rate, more than 10 degrees per second. But what is very interesting, it's the roll rate, because 3.8% of the time it is between plus or minus 10 and plus minus 20 degrees per second. And so it represents high solicitation to the bicycle. And then concerning the profile of the different ridings, so here you have the profile of the 26 motorcyclists and the general cross of the acceleration and the roll angle, your weight of the different volunteers. And as you can see, for example, if I see this one, we have smooth behavior with small braking, small angular velocities. But if I read at this one, for example, we have more solicitation. So it's possible to identify behavior of more sportive than another one. And also it's possible to classify what are the different behavior of the different volunteers based on the average behavior of all of motorcyclists. And for example, here you have extreme values with volunteer, with the crossing of the acceleration. And as you can see here, we have reached more than 1 meter, 1J on the acceleration and braking, which can be due to a very small peak during the hard braking, for example. And we can see that some people can reach very high roll rates, for example, due to high maneuver. Now results concerning also the riding profile. We have compared, for example, the profiles of two different volunteers on the same roads. This road has been performed 4 times by the rider M7 and 3 times by another rider M6. And you can see on the top that the different behavior of the two different volunteers. And of course, this behavior is dependent of the speed, and you can see here the difference of the profile of the speed of the M6 and M7. So, yeah. And finally, I would like to show you some results concerning the video analysis. So here you have successive different shortcuts of issue that we have observed concerning the PTW. So I would like to say it's very important that here you have only issue with the PTW, but also we have observed issue concerning the car. But here my topics is concerning the PTW issue. So I will not present the problem with the car, but we have the same for cars, of course. And if we try to do a small classification of the issue concerning this behavior, we observe curse cutting, as you could see in the beginning of my of a video. We have also vehicle interdistance very too short. We have lane rising without lateral space. For example, here you have a car who is overtake a truck, and the car is braked due to a speed bump, but the motorbike overtake the car. But in front of him, there is another car who coming. So it could be very interesting to analyze this kind of behavior and interaction between cars and PTW. We have also non-respect of stop and lights, and some problem also concerning overtaking on a straight line, on zebra, and so on. I don't know if I wait for the end of the video. The last. And in fact, the video, we didn't recording all the time the video. We record only 45 seconds. And in fact, the video is triggering when a specific high solicitation of a car is reached. And we keep the 30 seconds before and the 15 seconds before. So in order to have all of the continuum on the analysis of the situation. Okay, to conclude this work, the idea was to characterize the motorcyclist behavior, and specifically the motorcyclists with high levels of dynamics demands. And we have observed that for the acceleration and deceleration, they exceed plus or minus 4 meters per second square only 0.5% of the time. It could be seems very small, but in fact it's more than cars. And during cornering, so roll rates exceed 20 degrees per second only 0.8 per second percentage, sorry, of the time. And we have during 3.2% of the time a speed more than 130 kilometers per hour. This type of natural riding exposure data allows to characterize the vehicle dynamics of motorcyclists and to discriminate the different riding profile of motorcyclists. Of course, it's only an objective classification, and if we want, for example, to identify motorcyclists which have a risky behavior, it's not enough based on this data. And the next work is to correlate psychologists' profile with objective profile based on this event data recorder. And of course, as I said, we are comparing these results with the usage of cars. Thank you for your attention.
Yeah, thank you very much, Thierry, especially for holding it the time. And other questions? Please go to the microphone.
Matthias Kühn from Bosch, thank you very much for the presentation. Two questions. One is, how much does the traffic regulation in France influence your investigation, in particular the 80 kilometer speed limit on country roads and 130 on highways? And second question, how much correlation do you actually find within the data of speed and deceleration, acceleration, lean angle with risk driving? From the pictures you have shown, I couldn't imagine that there is any correlation.
Yeah. So concerning the first question, we didn't make the work about the influence of the regulation of the speed by the government. except that, of course, we have made lots of statistics concerning the exit speed of a motorcyclist reach during the driving, and so we have statistics on that, but I didn't present it today, but we have the data concerning, and of course we observed that in general the motorcyclist has more exit speed than cars. There is no photo. And concerning the second question, as I said, in fact, we are able to characterize a sportive behavior, but we cannot prove that this sportive behavior is a risky behavior. Be careful, it's not exactly the same, okay? And it's why I said that to identify a risky behavior, we need first to identify the psychologist profile of a motorcyclist by questionnaires and what is motivation to drive like that, okay? And if you correlate the psychologist profile with this kind of data, perhaps you could have a signature of someone who has a risky behavior. But it's the future. It's not yet.
Next question from Mr. Will. Can you switch on the microphone in the front? The first one? Or come here.
Sorry, try like that.
Yeah, take the other one.
I will make it second. Perfect. So, Sebastian Will from WVW. Two quick questions, if you allow. The first one refers a bit to what Matthias asked. You used the categories smoothest and sportiest riders, and I wanted to understand where these categories came from the GG diagrams, for instance. And the second question would be, if I understood it correctly, you showed a maximum trip length of 51 kilometers. So I wanted to ask whether you think your panel is more characterizing commuters instead of leisure riders. Thanks.
Okay, so I answer to the second question first. Yes, we asked the question to people if they use their motorcyclist as commuter or as leisure, and in fact, it was both, because we recording them during 1 year and a half. So sometimes they use as commuter, sometimes they use as leisure, and of course we have some information about when they use for commuters and when they use for leisure. But we have not performed yet the work to separate the two different behavior. And but what I would like to say is this kind of behavior, we have observed them, and we could say that about 2 weeks after the integration of the event data recorder on the motorbike, people, it seems that they forget that they have an event data recorder, because we observed some behavior that if you know that, you probably don't do that. And concerning the first question, sorry. Yes, okay. So to do the categories, in fact, we tried to find different criteria, and to find this criteria, it's for example the percentage of the task, not the task, sorry, the matrix, and the number of black points in the matrix that you have reached. So it could be one of the criteria, but also we based our criteria on the identification of the average behavior with 26 motorcyclists, and then based on that, okay, you know that this one is under, this one is upper, this one is the extreme, this one is the minimum, and so on. So we tried to find some criteria like that.
So, but please, very brief.
Maybe a short follow-up on that, because I don't know if that answer got in the right direction. How did you come up with the category smooth instead of, for example, sportive or extreme or whatsoever? So how did you choose your category name?
It's very difficult because you have to be careful on the name. Smooth because you have not lots of high demands on the motorcyclist. For example, when you arrive at a stop, you have a braking smooth and not hard braking, so you don't brake at the last time before the stop, okay? And sportive because, for example, at the start and go at the stop, you have big acceleration, so you want to reach very quickly the limit of the speed, for example, instead of increasing very slowly. Sorry, perhaps we could discuss.
Couldn't you be as well smooth and sportive?
Me?
Someone?
Sorry.
Isn't it possible to be as well a smooth rider but also a sportive rider? So how
yes,
do
of
these
course. One day
categories
you
match?
could be smooth, another day sportive, but
Same time.
no. Okay, we will discuss after during the lunch.
Yes, please, but I guess you will get many questions, so very interesting data you have. So thank you very much, Thierry. And we are coming to the next presenter, Florian Scherer from the Institute of Automotive Engineering, the TU Darmstadt. He worked as researcher there about a long time, and his presentation is development of a motorcyclist model for trajectoria prediction.
Yes, thank you.
Please.
Thank you for the introduction. I will switch to German as we have really good translators there, and I think I can tell you better in German what I want to say. So, I think my topic somehow fits to, sorry, I stick not to English. Ich denke, mein Thema passt sehr gut zu
I
dem,
think
was
my
uns Thierry gerade
subject
vorgestellt
will
hat.
fit in
Nun
really
möchte
well
ich
with what
nicht ganz
Thierry
so
just
statistisch an dieses
showed
Thema
us.
rangehen,
Just a minute, I didn't want to
sondern
approach this in
eine
such a
einzelne
statistic
Kurve
manner, but I
herausblicken
just take a look
und
at
dann einmal
one
untersuchen,
curve or one bend and then see how such a cornering one such a curve can be attributed to a specific rider behavior, and that's the trajectory prediction in the title, although that might be a bit too specific. Let's talk about motivation first.
In vergangenen Forschungsarbeiten
past research,
unter anderem in Zusammenarbeit
amongst
mit
other
dem
together with the WIV, with the Technical University of Dresden, we showed in the study that sort of the fear, the cornering fear, that you have certain roll angle limits. So we had 10 riders here, and what I show you here, so that was a secluded area, an airport near Darmstadt in Germany. And we have set up this comfort roll angle that we had those riders corner as often as possible, and then when looking at certain parameters it became clear there's specific limits. So there are differences between cornering to the left and to the right, and big difference between the riders. So if you take a look at rider 4 in this diagram, you have a distribution of the comfort roll angles that is much lower than, for instance, rider 7 or 8. However, contrary to that, rider 7 has no difference between right and left-hand corners in blue and red, whereas rider 5 have marked differences. So these tests showed us also we try to find if we can differentiate this comfort riding and stress that we introduced. So now take a look at the picture at the left bottom. So you saw something emerge that wasn't there, and we took a look at the changed behavior. So with this, there is a deviation of typical behavior of sort of 10, 12 times taking that curve if some of the limit conditions change. So in parallel, in a real study in the area of Würzburg, we had let people fill in a cornering fear sort of self-characterization, and we compared these values with the deviation of the typical distribution of the roll angles that are being taken by the quasi-stationary comparable value. It sounds a bit complicated to explain this in a more simple way. So what you see here in red, the riders in red, have given a very high fear rating, and they say, I'm really fear to go these corners. And then they chose a more direct line, for instance, by having to use less additional roll angles, whereas somebody says, I'd like to go in the corner a bit faster, I lean into the roll, I increase my roll angle, and therefore I have a different value in the distribution. So what I present is based on what you can see on the right, and that's research, for instance, was my Nins Magira, who found out that when we take a look at riding data in a statistical manner, such as Thierry did in France, we did in Darmstadt, and based on different comparable values that we developed, we can see differences in riding capabilities. Such a novice or somebody who doesn't cover many kilometers and hasn't got his license for so long will show a different statistical behavior, especially in terms of increase of roll angles and roll angle behavior, and also in the corresponding yaw rate. And exactly these findings I took, and I asked myself, is it possible to model and predict the future state of a motorcycle on the basis of a very simple, transparent model that doesn't need any vehicle specific, and to use this model to set up corresponding parameters for this cornering, and to use this by sort of predict a certain behavior of the vehicle. So how similar do we take the same curve under the same conditions? And so the requirements, rider-specific, the coefficients and the parameters we should be able to interpret those. And we also, what we wanted, we did not want use any motorcycle or vehicle-specific parameters. So we created data sets also within this roll angle fear study. We extracted some maneuvers, then we transformed this into a so-called curve process, and then we segmented it into maneuver primitives, then derived, or we applied mathematical functions, and then we derived these rider-specific parameters. With those, then we can say, okay, if we know these parameters and we know the deviation, and we can say the following curve will be taken in a similar way, so we transform this into time, and by calculating a yaw rate, and that we based on the current speed, we can actually work out future position. What we also needed here, that you see here as a correction factors, because we calculate the yaw rate, and do not use these sensor values, and the correction factors also also tell us something on the rider-specific behavior.
Wo hat das Ganze stattgefunden?
So where did we do this? I already mentioned this at the Griesheim airport near Darmstadt. That's the circuit that the participants took, all of them, 10 riders together, and this curve, this 180-degree curve, has been taken by each of the participants 6 times to the left and 6 times to the right, and those is the data that we used for the evaluation. And other than that, the riders took this curve and took this circuit as often as possible, and then we were able to look at this comfort roll angle curve. So we enter a progress area. So at the bottom length you see the passages by the same person in time, over time. So you see the number of passages there, and you see that you use a different speed to enter the curve, and perhaps also to have a different behavior over time. So that wouldn't be comparable straight away. So that's why we looked at the fact if there is sort of that at a similar point of a curve, you take a similar action, and therefore we decided to use this curve progress process, and we can take a look at any curve and segment that into from 0 to 100%. Then we relate to the curve primitive that we see on the right-hand side. So let me explain this. This is a phase diagram where I have the roll angle on the y side and the roll angle on the other. So when we go straight, it's a stationary state, and if we want to increase the roll angle, we need a dynamic phase with a positive roll angle. Then we take a right-hand turn. Then we have reached another almost stationary phase that is not applying to anything. The more times you change the direction in a curve, in a bend, you have more stationary parts. Then the end you have a dynamic with a negative roll angle rate and a smaller roll angle, and this arrow at the bottom, you have a transition to the next curve. That's a typical S curve. So we took a look at this primitive, and we thought about how we can have different phases for entering the curve and use mathematics to describe this. So after a lot of trying out for the initiating phase, we decided on applying a logistic growth function. It doesn't sound very motorbike specific, but we know this more from mice populations. So if you have a mice population that is very small and the conditions are really well, and there's an exponential proliferation of this until they have reached the limit boundary conditions, and it's a saturation. And this is similar to the increasing and decreasing the roll angle. So the stationary part, we applied a linear regression model and two sinuses overlaid, and you see this in the next step, and it was sufficient to prove the specificity with these parameters. But the certain swing of curve signs makes sense for the prediction, but not so much for the interpretation. So what do we derive from that? The more we see an amplitude or frequency in the stationary phase, the rider corrects the current behavior that can be due to different reasons, which I cannot derive 100%, but it is a deviation from the planned behavior and the actual behavior. Now, what does it look like if you take different persons there? So you have the roll angles in the middle, at the top, and in the middle the speed and the yaw rates. So there's a very specific behavior of these three different riders. So explicitly shown is the rider in pink. who is seems to be always at the sort of he decreases who decreases the roll angle in the middle of the curve, but that's not due to the speed, but by turning movement. And then again rolling in and to finish the curve there with the blue rider. We see a more stationary behavior. He is rolling quite fast, but he keeps this constant roll angle. And the black rider, he is running at a start rolling, and he increases and decreases the roll angle. That was very exciting to see this. That you follow your own patterns. So we have this sort of elliptics that you see here, the thrust ellipsis, and the wider these elliptic designs, and you see here whether we have a deviation in the roll angle or in the roll rate. So this relatively large area, the pink rider, shows that you can see a lot of swinging in this stationary area, whereas the blue rider is more constant. So now we take a look at exactly these parameters. So you see these three riders in the roll angle. So now you see the parameters that we derive when you take a look at the base value, gradient and frequency and amplitude. We see nice differences, but the yellow rider shows us this in the spider plot. So for instance, curve number 6 is slightly different from the others. There's a certain difference in repeatability. Other than that, we have a relatively similar diagram that shows that you repeat the behavior in these curves. So you get information on how much you correct during the stationary phase and how quickly you do this. So what you can say, we see specificities of the riders, and we use the same parameterization for the speed. Now, to talk about the trajectory projection. So what is, we calculate a future position based on the yaw rate and the yaw angle over time with the corresponding speed. That is, we need a yaw rate signal that we derive from a stationary process that we correct 3 times. I have to hurry up a bit because I'm too slow. To the pleasure of the translators and interpreters. So now, with the corrections we approached these values, and it looks like this. You see the 180-degree curve as a reference measurement, and then with the corresponding method and projected, and we have a low mistake of 20 or fault of 20 systems, and that we use this reference system with corresponding GPS correction. And the question is whether we can apply this in reality. But we see, if we take a look at all the riders, that we achieve a lateral error of less than 0.5 meters for 97% of the runs. So in conclusion, I'd say it is possible to use a simple and interpretable approach to describe a typical curve run of a rider, and to use this, you will take this bend in a similar way or not. Thank you very much for your attention. Yes, thank you, Mr. Scherer. Do you have any questions? So I would have a question. So of course, as somebody who is reconstructing accidents, it would be nice to know, with all your nice diagrams and roll rates, what was the radius of the curve? Yes, we have that. That was very that was a radius of 12 meters only. Always the same, always the same. But during this study, we also had other curves that we looked at.
etwas größeren Radien
with some slightly bigger radii up to 30-35 meters. And as a sort of a prediction, I can say, well, we're going to do this in under road conditions with similar radii of 50 meters, with higher speeds also. And at the time, we didn't have more room at the airport there. Well, we could discuss this in the future, because you would need the radii for the individual data. Well, it's not sufficient to have a range. That's one approach I showed for that. One curve. And of course, this is the basis for continuing our research. And how similar is this if I have a different curve or a combination of curves? I always think of the usability of the data. You focused on the driver situation of the dynamic behavior. But there's also the area of technical accident reconstruction that like to use such values. Well, you could also use this for infrastructural measures. If you took a look at comparable curves, bends, and then see same behavior, and you could put this down to the infrastructure perhaps, and not to the riders. Thank you. But there is also another question coming now. Hello, David Köbel from Traction X. My question is the vehicle parameters, the vehicle type, of course, had an influence on the predictability. And what are the findings that you got there? That was an intention to not to use vehicle-specific parameters. And we just choose one point, mass that is moving, and we carried out this test only with one vehicle. That was our intention, and they all used the Honda NC700X. And we're going to do this now with other vehicles. You perhaps see different behaviors, but the typical user behavior is that you mainly use your own motorbike or two without. We could describe this without using our knowledge, so that could be used in a more extensive. We saw smartphones as measuring technology. That's getting ever better. And with standard IMU and GNSS data, of course, you need a good estimation of the position at the beginning of the curve. Just a very short question. So that was a stationary running around in a circle to determine the position. Do you see any potential also for normal curves to bring about such predictions? Thank you for the question. Of course, that is a very good question, because the difference here is that we have a curve with a constant radius from second 1 on, and which is not typical for the road conditions. And therefore we have different behavior on the road, but it also works on the road. It's possible also to describe and predict typical road trajectories, although you have to know where the road, the course of the road is going. I'm interested in the speed. Where were we in this curve, at which speed? So, well, the average was between 30 and 50 kilometers per hour, according to the typical behavior. And as I said, we would have to also do this in higher speed areas. But what's good that I showed with relatively low speeds in this small curve, we get a lot of information whether somebody is a good motorcycle rider or not, because you need a lot of capabilities to remain stable. You need a lot of experience, and that's what is reflected by the data. But that was the second gear, wasn't it? And that is so difficult to ride in a similar way. And that's why we also had the novices that we could take out of this data. Another question from Mr. Zielen from Bosch. So interesting method that you showed. My question would be, what do we do with this method? Can we use this to advise individual riders how to take a curve? Can you derive questions to manufacture for manufacturers? So, and even further, if that works, the method works, wouldn't you also have to talk about the road structures and the road design? Well, those are great approaches, and we did this also with two approaches. It is to show the typical behavior and then to work on that. And we also at the Technical University Darmstadt, we work a lot with rider trainers, and we also research into investigate if we see typical changes in behavior at the beginning and the end of a training session. That's one of the underlying ideas. Yes, thank you very much.
Wir kommen jetzt zum letzten Vortrag dieser Session.
Now that brings us to the last talk.
Matthias Kühn von der Unfallforschung der Versicherer in Berlin wird
Accident Research from the Insurance Industry.
Known Accident Pattern, Motorradfahren in Gruppen, also bekannte Unfallmuster darstellen.
Motorcycle riding in groups, known accident patterns, we will introduce to us known patterns.
The German Insurers Accident Research, der Unfallforschung der Versicherer.
Thank you very much for being here. I want to present you today our results regarding an exercise we did with our accident database, not as complicated as all these dynamics we've seen before. I prepared this presentation in English, so I do it in English. So it's unfortunately I do it that way. So where we are, you can see on the next slide, we are from the German Insurers Association. We are an insurance accident research located in Berlin. We are commission research with universities, doing our own research in the fields of vehicle safety, infrastructural aspects. We are dealing with and behavioral aspects because you know everything for road safety based on these three main pillars. And what I want to present today is already published 2 years ago, I guess. It's called Motorradfahren in Gruppen, so riding in groups in our accident research compact, as you've seen on the slide. So, as you know, and that's unfortunately the same for years, riding a motorbike in Germany is associated with a high risk. So it's risky almost, or the risk is almost 20 times higher compared to be killed on a bike compared to the risk in a car. Unfortunately, this risk is rising, and our job is to find out what we can do to lower this risk and look at the fatality rates and the fatalities in Germany. Each and every year you see that the number of car occupants is decreasing and the number of vulnerable road users, bicyclists, pedestrians and motorcyclists is rising. And our job is it to turn that somehow around, and what we know is, meanwhile, there are no big pieces anymore. We have to touch and do something in order to improve road safety. That's a lot of small pieces we have to address in order to be better. And that's one exercise today. We figured out by accident that it's quite interesting to look at groups and riding in groups and certain patterns we might be see there. And in the next slides, I want to just show you the approach. That's our accident database and some facts to that, the results, a summary, and finally the measures and some impacts of measures in general. So we did this study with our accident database from German insurers, so that's incorporated all third-party vehicle claims with personal injuries and at least 15,000 euros of costs, a total claim value. That means that more severe accidents, but we are quite confident that we cover a big picture of the accident scene here. So this accident database grows and grows every year, so roughly 11,000 cases we already incorporate there. And for this study, we take these 2,345, I guess, accidents involving motorcyclists. And now it starts just step by step, and creating this picture you maybe already have in mind if you talk about or think about accidents of motorcycle groups. So if you look at these pattern and try to quantify it with numbers, you will see that, as I mentioned, we don't talk about this big picture, these 50 or 60% of accidents. That's not the case. That's 15% of accidents, and that's, in my perspective, it's quite a high number. And that's 50% of accidents, but, and that's one minor thing, we will go more into deep in the next slides, 20% of parties involved. Which parties it are, we will see in the next slide. So, and then we come to the results regarding the location. So quite simple, and as you maybe already assume, is that the location, the accident locations between single rides and group rides differ. So you see the single motorcycle rides, we see the picture you may already know, that we have rural areas addressed and the built-up areas, so the city areas where you have a lot of these two parties involved, left turning accidents and so on, and you compare that with the group rides, and you see that group rides are a little bit different because you have the rural roads and the outside built-up areas in the accident scene with roughly 75% here addressed, and that's already a characteristic of group rides, as you probably already assumed that you do it for leisure, that's kind of a hobby, that is fun, that intrinsic motivates, but as you see, the accident scene picture this somehow. And if you look at the models, for two-wheeler models, you see at least one striking thing is that scooters are not really involved here. That's more the bigger bikes, that's the sportier ones, the more comfort ones, because that's what you use if you go on a group ride. Here, other picture shows you that the opponents, and that's one interesting part we are putting in the result later on, is that the two-track vehicles like cars and trucks and so on, which are normal ways for single rides with 76%, the main opponents of these motorcycle crashes are not as high as in the single rides. In group rides, you see here that you have this almost 60%, you have other power two-wheelers incorporated, and how that picture is built up and created, we will see in the next slide. So you see that two-track vehicles, cars and trucks, are with 30% not as often involved as in single rides. And another general thing before we go more into depth is that the age distribution. maybe small picture or small pattern we can see here is that in the age of 42 to 47, that's our data here, so in the mid-40s you see a higher share of involvement in group ride accidents, and you see that small shift to older people involved in these accidents in group rides, and more younger people involved in single rides. So that gives you or add another piece to the assumption that this higher attractiveness of group rides as a leisure activity among other motorbike users is here the case, and it is special in a certain way. And you see now we go into depth and look at the accident types. The accident type describes a conflict situation which leads to the accident, so it doesn't describe the accident itself, but the conflict situation which leads to the accident. And you see that the driving accident and the longitudinal accident here are on the first places here with group rides, and you see that in the single rides, all other accident types like turning and crossing and so on, because of the city accidents we are a little bit missing here, and the group rides are not as often touched in the group rides. So we see that the group rides have a special pattern here, and these driving accidents we want to do more into focus in the next slides. The driving accidents have a high proportion with oncoming vehicles in general, so that might be power two-wheelers, that might be two-track vehicles, cars and trucks and so on. And that's describes the kind of accident, so that's definitions we use in the accident arena in order to describe accidents in general by definition, so we can compare it with different institutions and other analysis. And you see that these oncoming vehicles might be an issue, and it leads at least in my mind, picture you overtaking accidents, for example. Typical patterns we will see in the next slide. Compared to single rides, that's a picture you already know. You see that leaving the carriageway, so mean to the right or to the left, so you leave the road. That happens more often compared to the group rides. And look at now, stay at driving accidents and group rides, because that's our issue we want to discuss here. We see that if you look at the failures by the riders in relation to, and you see here that speed, road use and overtaking and kind of a misjudgment is described in the accident files here. And if you look at the accidents in group rides with lane departure, because that was the second on the second spot, the accident types, you see that the combination here is speed at inappropriate speed somehow, distance and road use. I tried to explain it later on, are found in these data description if you look for failures in these driving accidents. And now if you try to look in the pattern and try to understand what is the reason here and why happened it that you don't have less two-track vehicles, why you have so many power two-wheelers in these opponent ranking. You see here that if you have on the one hand on the first place the overtaking and collision with cars and trucks, that's okay with 30% roughly, and on the second place you see the overtaking collision with oncoming power two-wheeler riders. So sounds quite strange somehow. There's a group and you overtake and you hit or collide with another power two-wheeler. I mean, the power two-wheeler has the same problem like a car driver because of look but fail to see somehow. It seems, at least that's the data shows us, it seems to be the pattern here. And another point, and that's quite interesting, and one thing we have to work on is that the collisions with other group members during high dynamical situation during overtaking. And these collisions with the own group members is a special thing we have to work on, as I said. And when we overtaking, you see that that's what the data says. Distances are too small, the side distance is too small, you drive side by side, front and rear following distances are too small. So that might be an explanation for these high numbers of collisions with own group members. And if you summarize this is a quite small and easy picture that you see that it's 15% of all accidents involved motorcycles are group rides. So that's the first number, which is not as small as I thought at first. And there are certain patterns involved in these accidents. And it's striking differences. That's a proportion with these collisions of own group members. That's striking, as I said, and in numbers here we have 225 group accidents and 360 riding members involved. And that is because of unfavorable group dynamics, we called it, regarding speed, safety, distance, and own inattention somehow. And as you see here, there's no, at least for the next slides, there's no technical measure involved I can think of which can deal with these issues. And that's the last part of the presentation, that's measures in general. So if you have these results, and these accident data should be the basis for every safety measure we have. Doesn't matter if it's motorcycle or agricultural tractors or pedestrians or cars, there's still the same thinking, and the basis should be accident data. And you see here this kind of hidden matrix, active safety and passive safety on the one hand, and the vehicle, human, and environment on the other hand, just to get a feeling which measures have which impact. You keep in mind that technical measures have a strong impact, they are stable in their impact, but it takes time to come into the fleet. The dissemination of the fleet takes long. I mean, it depends on the car. Is it a car or is it a truck or is it a motorcycle? I will show it later on. So if you have the behavioral measures, and that's maybe the measures we are talking about here, is that they have the characteristic that they are short-term, the impact is really in short-term available, but they are stable with enforcement. That's falling speeding, for example. If you talk about speeding with cars, for example, you can have kind of an impact in road safety if you enforce them right. Infrastructural measures, they have a mid to long term, somewhere in between impact, and they are stable. For example, road barriers is one point you can make here. And if you look at these in a different way, you say you have a target you want to keep or you want to improve road safety, then you have different measures, as I said, and knowing the characteristic of these measures, you know, if you want to reach something in 2030, that's 8 years farther down the road. That's in terms of measures and their impact not really far away. You won't reach something with technical measures. Because it takes too long to disseminate the fleet. And you see here the gradient of this linear curve depends on the kind of type of vehicle. So it's for motorcycle, unfortunately, it takes even longer because motorcycles in the fleet are older than cars or trucks, for example. And behavioral measures might be one way to go. And that means for us, we have to talk about this. We have to communicate. We have to tell them. Every rider should know what might be a reason for accidents in group rides, and that's the way we see this topic. I can't see, as I told you before, I can't see a technical measure which can help here. Maybe you have some ideas, and we can discuss it later on. So that's really in short what group rides are about, based on accident data. That's our focus on these special issue on motorcycle accidents. Thank you for your attention.
Yeah, thank you very much, Mr. Kühn. Are there questions? Yes, please go to the microphone. I guess the front microphone is now intact.
Yes, it's working. This is Colin Ballantyne from KTM. First of all, I assume your definition of a group was more than one motorcycle, so also 2 bikes were considered a group. And in the data that you analysed, was there any correlation between the quantity of bikes in the group and the accidents?
It's an interesting question. You are right, at least 2 form a group. I can't remember really a pattern with this direction you probably have in mind. So I can't see this, no.
Okay, thanks.
Welcome.
But to this question, I have also the question how you could analyze the group, if it was a group. Was it because the police is registering and is taken participants into this? So this car driver is number 1, this is number 2, and then you can analyze. But not each case in which 1 or 2 or 3 motorbikes are driven can be accounted in a police report.
Right.
Do you have bias cases inside this?
So it's not easy to analyze it, and it's not possible with just the police data and just the police reports, because you won't figure out that this accident is a group accident, because the second or third group member is not involved, and that's why it's not in the police data. So that's why we have this database and we have additional data, and we have a bias for sure, but we tried case by case as good as possible to get into these accidents and figure out by witnesses and so on who was involved and who was a group member and who wasn't. It is not easy. That's why the case number for the group rides is not as big as you probably think if you go into analysis. But that's why might be one reason, because you found not really a lot of analysis regarding motorcycle group ride accidents. So it's the hardest part to put these categories right.
So the number you presented is a minimum number. It could be much higher.
That's I would say so. Yeah.
Yeah. Please.
Question maybe goes in the same direction. Does your data provide any more information about the composition of the groups? For example, is that a group that is constantly riding bikes with each other since many weeks or months or years? Or maybe is there some participant in that group who's new to that group and he's the issue?
Yeah, unfortunately, these deaths we can't reach. I mean, if we are lucky, we have a witness which says, "Oh, that was a new one. It's his fault because it's a first ride." But that's really seldom happens. So, if you deal with accident data, the problem are the details, and maybe in the details there are some solutions and some answers to our questions. That's why, to answer your question, no, it's not possible. And for me, I don't I don't see any other measure or answer to the problem here as telling them what might be happen, what can happen, telling them in trainings and so on. That's the way I guess it should be.
Okay. Further questions? Yes, there is one. Dimitri?
So thank you very much for this interesting presentation. I'm just wondering whether you can, or you're interested to cooperate with a German institute in order to collect control data. And I have to say that in the whole conference, only one mentioned, and it was Sebastian, about control, maybe because Sebastian is a psychologist and we, the engineers, we don't know exactly what control group is. So to collect data in order to see the significance of your symbol, the accident symbol. Otherwise, we can blame control groups of riding that maybe the occurrence of the events are not statistically significant. So someone has to collect data from groups that they are not involved in accidents.
Right. I mean,
and you have actually the authority to interview the people that they are insured. So we as engineers or the research members, we are not allowed anymore with the GDPR to intervene to someone else's life. And
you're totally right. It's interdisciplinary. That would be the next step in this project, to take our psychologists and say, okay, ask people, not people which are involved in accidents, just riders which are using or riding in groups, and ask for how often you do that and all these stuff in order to bring that together and say, is it a problem, was it no problem? You are totally right. That would be the next step, and that would be necessary in order to come up with measures and to communicate and to
thank you very much.
Tell them that.
But this brings me to an idea which could be a possibility which you can go further on. There was a cost study in some years ago about bicycle safety and safer two vehicles, and there was, I think, like a control study. They made a questionnaire about riding, and perhaps you can find out how many are working or riding inside groups, inside this database.
That would be the next steps. You are right, yeah?
You have only to use these data sources then to ask how many cases are existing.
I can use this questionnaire maybe, and
Okay, thank you very much, Mr. Kühn. And we are at the end of this session and the morning sessions at all. Thank you to all presenters and also to you as audience with so many questions. So now we have lunchtime. Thanks.
To those who ride them, powered two-wheelers, or motorcycles and mopeds, are loved for obvious reasons. Value for money, time saving, a low-polluting travel option, and an opportunity to use the vehicle simply for the pleasure of it. And they are popular. More than 40 million are on the road in Europe, with 1 million built across the EU and 1.4 million sold in 2019 alone. And for their makers, the scale and scope of the industry is lucrative, with 43 factories and R&D centers across the EU and the UK, undertaking the manufacturing of vehicles, trading, design, and much more. The scale grows further when considering the extended network of companies active in retail and wholesale, of vehicles, repair and maintenance operations, and the manufacturing and sale of protective equipment, such as gloves and helmets, suits, boots, and much more. Financially speaking, the motorcycle industry is an economic growth engine. Across the EU, it generates 21.4 billion euros of GDP, a higher sum than that of Venice, Malaga, and Palma de Mallorca, or the entire economy of Iceland. It also supports 389,000 jobs and creates 16.6 billion euros in tax revenue. Of course, one of the great appeals of motorcycling is its contribution to tourism and social functions of all sizes. From local club touring to arena-filling events, both riders and spectators eagerly participate in this thriving community. Events such as these have positive economic impacts on tourism. Riders and spectators travel to the events buying food, drink, merchandise and souvenirs, paying for campsites, hotels, and buying tickets. Collectively contributing 2.1 billion euros to Europe's GDP, supporting about 38,000 jobs, and creating 1.2 billion euros in taxes. MotoGP and Motocross GP races alone attract 1.5 million international race spectators annually. Collectively, they spent 319 million euros attending race events across European countries in 2019. But to see the biggest societal impact, look no further than our own cities and towns. Everyday use of powered two-wheelers is ideal for urban mobility. Trips in high traffic zones, short traveling distances, and requiring limited space for parking. They save enormous amounts of journey time. If only 5% of European car commuters switched to motorcycles, the aggregate time savings would be 21.2 million days per annum. Two-wheelers are very affordable due to their low fuel and operating costs. Commuting by motorcycle costs about 1/3 of the amount needed to use a car. And environmentally speaking, the average two-wheeler on the streets emits less than half of the CO2 of an average-sized car. Even better, the more common smaller two-wheelers produce even less than that. So it's clear to see. Powered two-wheelers offer significant benefits to the European economy, to European mobility, to European citizens, and to the environment.
So good afternoon from Cologne, Intermot and the IFZ conference. Welcome back for those that were here for the last day and a half attending the conference. And welcome to those that actually are joining for this roundtable, which is organized by ASEM together with the IFZ. And the title of the roundtable is The Motorcycle Industry's Future Within the EU Mobility Transformation. What is the vision 2030 plus of the industry and what does it entail? So before we enter the subject, just a short introduction from my side. My name is Antonio Perlot. I'm Secretary General of ASEM. I'm very glad to be here after, I would say, a hiatus of, well, 4 years, if you think about COVID. Good to see many people that are known in the audience, and I'm sure many more also connecting online. I'm glad also not to be alone, I would say, for this roundtable physically here in the room. I'm also joined by Helfried Sorge from KTM. I will introduce him in further detail later on. And we also have many speakers on the line that will be supporting the discussion today. We have about 1 hour and a half time for this exchange. I've been told you can also fill the stage, meaning that it's only the two of us here, but obviously the audience can also help with questions and contributions. Those will be very welcome. And the audience online is able to send information, questions, also via a feed that is available on the online tool that you use to connect. So maybe before I move on with the program, a short introduction about what is Vision 2030 Plus. You see a slide here on the screen, I hope also at home. This is an initiative that the industry has launched basically last November at the occasion of the 2021 conference, after, I would say, a long period of gestation of about a year, even a bit more, thinking about what are the challenges of the future. We've been talking about the new normal after COVID. I think that's one big question we all have. How will we move around? But if we look beyond, there are, of course, challenges, and especially in Europe, the European Union has taken, as you know, initiatives that are aiming at achieving sustainable mobility from all perspectives, whether it is from the mobility itself. Of course, mobility should support wealth creation. This is very important for any region. But it should also look at preserving the environment, ensuring that there is health and safety for people moving around and for people moving with different means of transport. In our case, of course, also motorcycles are included. And of course, it should also mitigate climate change. These are all topics which were present before COVID hit. Obviously, they've been gaining even more, I would say, visibility over the last 2 years, and this is the reason why the industry really felt there was a need to position our vehicles, the vehicles that we are producing and the vehicles that many of us are using, many of us here in the room, but also beyond the room itself, an increasing number of people, I must say, even during COVID, showed to use two-wheelers, and how these vehicles can be made more sustainable. So, I don't want to enter too much into details at this stage. You saw a first video which is showing what the sector is about. We thought that is important, I would say, to present who we are, even though the people in the room know that very well. But the ASEM vision was really aiming at addressing all the, if you like, negatives that are associated with mobility and trying to position the power two-wheeler with a vision forward at the horizon 2030 and beyond. So this is the result you see here is a schematic depiction of that vision. We will discuss it today. There is more information on our website with a series of position papers I'd like to invite you to go through if you haven't done yet so, to basically complete the picture. But without further ado, I would like to enter the program, and we will start first with a keynote speech from the ASEM president, Michele Colaninno. I'll briefly introduce Michele Colaninno. He is, as I said, ASEM president, is also director of Piaggio and Company SPA, and chief executive of Global Strategy, Product, Marketing, and Innovation. He's also founder and chairman of Piaggio Fast Forward, the group robotic company headquartered in Boston, USA, whose mission is to develop innovative mobility solutions for the future. In addition, Michele Colaninno is Chief Executive Officer and Chief Operating Officer of the IMSI Group, an industrial holding active in the financial, real estate, and industrial sectors listed on the Milan Stock Exchange. So, Michele, I believe you're on the line. Yeah, here we are. So, good afternoon. The floor is yours.
So thank you, Antonio, for your introduction. I just want to briefly describe what industry is still in the field of mobility that we are investing in entrepreneurs and managers. As the video pointed out, we are facing, fun, mobility, and commuting opportunities for our products, as goes from two-wheel with thermic engines to two-wheel with electric engines, and hopefully to two-wheel with other technologies that will fulfill the needs of today. Surely we are facing the worst period after the Cold War. You're in a situation where the crisis in Ukraine is, putting efforts to every industries in the world, and unfortunately, this is a momentum where, perhaps fear and uncertainty is taken part of our everyday job. But being positive and hoping that the situation will be solved sooner than later, what we have in mind as ASEM in the future of mobility. We all know that we have to take care about the futures of our children and of our families. And we are part of the green revolution that is taking, biggest stage every day in every sector of the industry in the world, especially in Europe, by the way, where the European Union is helping us to invest more in new technology. What I say is that through new development of laws and other ideas that the European politics are putting on the table, we are developing products that will not for sure be the same product of today. We will invest in new technology and hire more people. And this is one of the most relevant things we have to take in mind when speaking about industry. So hiring people, new technology that will help everybody to have a safer life and a better quality of life, even if we are working for fun, mobility, and also sometimes for delivery of goods, because two-wheel vehicles can also be used for those situations. As I said, we are in a world of new technology, and we know that the evolution that we are now entering will help us a lot to reach the target of reducing pollution, not just in Europe, but all over the world. We are now speaking about Europe, so I would say that the investments that every industry is doing are going to be full efficient in about 5 to 10 years, I would say, because we know that new technologies need not just investments from industries, but need a world that must evolve in this situation. So we need infrastructures. We need regulations that have to be, aligned state by state. We need to have time to develop these technologies. I personally think that we as entrepreneurs or managers should be somehow free to decide which is the best technology to put on ground in order to reach the target of reducing pollution and having better mobility solutions for everybody. So we know that electric mobility is now the topic that everybody of us is reading on newspapers, having sometimes we are buying vehicles, sometimes we are just trying vehicles. But in my view, and this is also the vision that we have at ASEM in when we debate about the Vision 2030, there are other technologies that we can develop and where we are investing and that we are researching. So mobility is not just a field of commuting from A to B. So that's why we have to be very pragmatic, because at the end of the day, costs must be lower than revenues. That because the industry has to proceed in hiring new people, creating jobs, and investing. Not just to give the better solution and the best quality and the best products that we can do and that we can give to the customers, but also to offer new mobility solutions that are not just the vehicles. I mean infrastructures. I mean technology behind the electromobility, investments that coming from all the world, all part of the world that must be in Europe just to fulfill the needs of supply chain and just to be able to be the best in the world. This is what I think, this is what ASEM is doing. We are putting a lot of efforts and doing a lot of studies in order to understand which is the right path and which is the better solution to fulfill the needs of our customers and all people moving around. We know that the power two-wheel vehicles and the technology around this can contribute a lot to the target that European Commission has given us, or that are thinking, or that will put on the table in the next 20, 30 years onwards. The diversity in our range from mopeds to motorcycles are they can fulfill all the product lines that we can think about. And I'm sure that industries will evolve, no problem. Technology is not an issue. We have great ideas in mind. Everybody in the ASEM Association is continuously stimulating dialogues for new technologies and new ideas. So we are not afraid about technology. We are just analyzing, I repeat, in a pragmatic way, which is the best solution to fulfill the gap and to reach a better solution for non-polluting vehicles, decarbonization, new infrastructures that must be built by municipality or states, because we cannot do everything as the industry is concentrating on developing products. Safety is another issue. We are strongly convinced that active and passive safety of our vehicles has done a tremendous job in the last 10 years. Our products, the products that we can show to the market, are growing and are proposing better safety solutions, so to avoid incidents or problems downtown or even outside the cities. So it's a whole world that has to move. It's not just the industry. It's the world of politics for sure. It's the world of entrepreneurs. It's the world of suppliers, and hopefully, when the situation will be better, I'm speaking about the geopolitical situation, everything will come to normality, and we will be concentrated in going on this path. For sure, this year has been a difficult year. Next year will be difficult too. But as long as we are positive as we are, everything will come to normality, and I hope sooner than later, as I said before, and we will be able to go on in investments and technology for our products. This is what I have to say, Antonio. As you know, we are continuously pushing our colleagues to have new ideas, because it's just through new ideas and new technology that we can evolve. We are continuously pushing everybody at the ASEM level to speak with politics, European Commissions, state level, majors, to explain that we are one of the intelligent solution for mobility in Europe and outside Europe. Last but not least, robotics and software are coming into our world, and I think that the junction between robotics, marketing, that is a part of our business, but robotics and software will take a bigger part in the future. And for sure, these new technologies that everybody was aware about will help us to develop what we are thinking for the next 20 years. Hopefully, and for sure, competition around the world is what push all the industry to do better. And in the beginning, because we are just at the beginning of this worldwide transition, we don't even know what happens in the next 10, 20 years. I'm convinced, I repeat, because this is one of the interesting field where we are developing the strategy for the ASEM, participants. The transition is made to competition, but the technology, the neutral technology, is the key. If you tell someone to do something, then he can decide which is the better technology, the better way to achieve the goal. I'm convinced that it's not by thinking about just one piece of the cake that we can reach the goal, but we have to think about the best ingredients to do the perfect recipe. And the recipe is to create a better world for tomorrow morning, not just in 20 years, but we have to think about tomorrow morning, because the problem is there. We see the problem of pollution. We cannot avoid it. We cannot think about this, and we can solve it. I'm totally convinced. There's no problem on it, but we have to work together, and just working together and creating solutions. I repeat, solutions for the mobility of tomorrow. We can achieve the goal, and we can win. Mobility of P2, power two-wheel vehicles is one of the better solutions for the mobility of tomorrow. I don't want to steal more time, Antonio. I'm here to listen to the roundtable that is very interesting for today. Unfortunately, I'm not there but you know, it's my problem that, and we have to deal with it. That's it, Antonio, and ready to answer if there are questions. But I think that the strategy we have in mind is just to be the solution for the mobility of tomorrow. Thank you all. Thank you for being there. And I'm honored, obviously, to open the discussion of this roundtable that I think is very interesting, and where people will suggest ideas to be part of the solution.
Perfect. Thank you. So, thank you, Michele. I think you hit the nail on the head, as they say, many nails, I must say, because the purpose here today is to engage with a group of, I would say, scientists. Academia is in the room. This group is mainly historically dealing with safety as a topic, and clearly that remains a clear focus of sustainable mobility. But even in the program these last 2 days, we had presentations on electromobility. There were, I would say, presentations also on decarbonizations at large, which I'm sure will become an increasing part of this, probably this conference program also in the future. If I don't know if there are any direct questions. I'm looking in the room, but I would also suggest that we come back to those questions probably later on, as we have a Q&A section in the program. So having said that, I would continue then with the program, and I hope you will be able to follow at least part of the discussion, Michele. Okay.
Absolutely, yes. I'm very pleased with this thing, and find you are here.
Yeah. All right. So moving on, as we identified the challenges, and as was mentioned in the speech, the ASEM vision is really looking at making our vehicle a solution. If I think about the different usages of our vehicle, we talk about leisure, we talk about, I would say, also urban mobility. Depending on where you go in Europe, there are different kinds of usages. We all know that there are different kinds of vehicles, as was said also in the speech by Mr. Colaninno. These vehicles, in their diversity, provide a lot of solutions for mobility and leisure. And this is one of the things we will for sure focus on today. Maybe if I then move on, because the other point is we have this conceptual vision. The objective is to have 3 manufacturers presenting how they interpret parts of these vision in practical cases in their own lineup plans for the future. I have basically 3 speakers that will intervene from the industry. I will introduce them progressively as we move on. And as we mentioned that the focus is on innovation, and the European Commission was mentioned, I also have the pleasure of having in today's discussion Maurizio Maggiore from DG RTD, who will come in after the 3 presentations have been made. We will then move into the Q&A, and I would say discussion, also interacting with yourselves and those connected remotely. So I maybe start with the first of the presenters, and this is a remote presentation again. So Eric de Seine is basically on the line, should be with us. Eric is an ASEM Vice President. He is President and CEO of Yamaha Motor Europe. He's also Senior Executive Officer at Yamaha Motor Japan. Basically all his life, I would say, has been dedicated mainly to motorcycles, whether it's from a professional or also from a leisure, I would say, hobby point of view. A lot of interest there, and before he was also CEO of Yamaha Motor France. So Eric, welcome. I'm glad you can join us remotely. And I'll leave you the floor to present what is the Yamaha interpretation of the vision, with a focus on safety, because this is what we were hoping also you would be able to bring to this table, given I mentioned the audience is very much, I would say, specialist in this area. Eric, please. You have to unmute yourself, or we don't hear. Yep.
Yeah, sorry.
Perfect.
Thanks to the technology. So first of all, good afternoon all. Obviously, I'm sorry not to be physically there with all of you. However, the topic is obviously important. This is part of my life, but more important, this is part of Yamaha responsibility and mission. First of all, I would like to remind that during the last 20 years, the progress have been there, and the statistics are demonstrating that the motorcycle usage, scooter usage, fortunately, is less and less dangerous. And we have seen in Europe the fatal accident decreasing by 44% in 20 years, which is a significant progress. But also in the same time, the active park has been increasing by close to 30%, which means that the net progression, the net improvement is really around minus 50%. We could be satisfied, but it's not enough. By definition, we must continue to trend. There is a manufacturer car who say, in our car, we would like to achieve 0 fatal accident. This is a dream for all of us, obviously. We know it's super tough, but we have to work on it. And we have been working on it during the past years. And I will say that today, the way we try to improve the safety conditions for our users, but not only for our users, also for the society around, because motorcycle usage is not isolated in the middle of nowhere. We are part of a society. We have to respect the bicycle, the pedestrian, the car users, all the others. We are part of the mobility world. And for that, during the last years, and we continue to work on it, we have been playing with 4 domains. The first one, obviously, has been how to improve the passive security of our vehicles. And in general, the main improvement has been done in relation with electronic devices like ABS, like TCS, which means traction control system, avoiding to slide if you control not so well your acceleration, and especially under the wet conditions. The TCI take the control and avoid this kind of risky situation. And all these devices have been implemented on our vehicle, from big bikes to mid-size bike to now entry level. So even today, the majority of the scooters, 125cc, are equipped with these devices. And it's obviously very good. I just would like to remind that the intention of motorcycle industry has always been to equip their vehicle with this kind of device as quick and as soon as possible. And fortunately, in general, all these devices at the start are always too bulky, too heavy, too expensive. And I clearly remember when we have been implementing ABS system, BMW has been the first one, Yamaha has been the second one in 1992. It was already 10 years later than car. But just because at the beginning an ABS system was like a shoe box, and the weight was more than 5 kilos, and to position a shoe box of 5 kilos in a motorbike, it's not an easy exercise. It's super tough, super difficult. And also the cost of this device at that time was representing 5 to 10% of the car value. But for a motorcycle, it was representing 20 to 30% of the value. So we have to accept that in our industry, we need miniaturization, capacity, lightweight before to be implemented. Until we cannot achieve a certain level of performance, it's super difficult. However, we did it, and we could see the result in that field. The second domain where we have also improved, connected to this passive safety, is the quality of equipment, helping the riders to control his bike. Electronic is one thing, but also mechanical. And with the improvement of suspension, braking system, tires, we have many components where we have been working with our partners, technical suppliers, to increase and improve. It can also concern the lighting system, how to be more visible, and how to improve the way the riders will always ride under safe conditions. The second level is the passive safety, which is finally also connected to the equipment of the riders, the way you ride. So as manufacturer, we did a lot of campaigns, and also we have been training our dealer network to know how to sell, how to support and convince our customers to invest a part of the price in their safety equipment. Quality of helmets, quality of jackets, quality of pants, quality of boots, gloves, and now even airbag system. So there is a strong effort, and we can see that if 10, 15 years ago, Germany was ahead of the rest of Europe in terms of passive safety equipment for the riders, we can see that now, year after year, all countries are following that trend, and now the level of equipment is much better than it was, and it has been also contributing to the safety. The third program, where also as manufacturer we can have some responsibility, and we took our responsibility, is everything related to education programs. We have in the motorcycle field riding schools, like you have driving schools for cars. But on top of that, we have been encouraging structure where you can have additional training, additional education program to continue to progress in your skillness, in the control of your vehicle. Also, we have been encouraging all the riders who were looking for a leisure usage of their bikes, and let's consider even to ride fast. Then we have been developing many programs of track days to get access to the circuit, to the infrastructure for a very cheap price, to be sure that these kind of riders who are motivated by the performance can enjoy the performance on secure track, totally with full safety equipment and with bikes which are appropriate to this usage. So we have been pushing out of the roads all these users who are now understand and they exert their leisure in this kind of full safety environment. And it has been also contributing. And the fact that we are selling less and less what we call super sports bike is really showing that now the customers have understood that race is race, sport is sport, and mobility and road usage is another story. And now it's totally in the spirit and in the motivation of our customers. The fourth domain, which is perhaps now the most promising, is about connectivity and electronic. We know that the major reason, the first reason of the fatal accident is about the collision between a motorcycle and a truck or a car. And obviously, the fight is not in favor of the motorcyclist. When you are motorcyclist, you are vulnerable, and we have to take care of this. And this is why, since 2014, all the manufacturers or some selected manufacturers in our fields, in motorcycle fields, have been starting to build up a CMC, which was the Connected Manufacturer Consortium, to work about what is the technical words is CYTS, which means the Cooperative Intelligence Transport System, which means finally how to develop a communication means which can connect all the users on the public road to be connected together, and finally supporting to prevent the identification and visibility of the other users you will cross soon. And for motorcycle, it's obviously particularly valid because in general, when there is an accident, the car users or the truck drivers say, I did not see, I did not saw. I was surprised. For me, there was nobody, and suddenly the bike was in front of me. So if we can detect and prevent in advance the zone where you have the risk of collision, we will support the safety for the car users, truck driver, but also the riders. So we have been working during 5 years, and Yamaha was active part of this consortium, and we have been testing different protocol, different equipment with our vehicle, TMAX, FGR, so different model of motorbike. But again, it was not just Yamaha. We were all together, all manufacturers trying to find the best solution and to determine this protocol. Now we are arriving at a point where the technology is there. We know that also that the infrastructure are ready to accept this kind of connectivity. The efficiency of this system obviously will be fully efficient if all the vehicles are equipped. And this is the limitation of this development now. It's just to see how we can spread, we can impose this protocol to be sure that now all the new vehicle will be step by step equipped with this device. And then we will have the possibility to be identified. To secure the efficiency of this system, we are also working on more electronic devices being equipping the vehicle on board. I speak about cameras, I speak about radar. I did an experience recently. I could enjoy to be trained on a Boeing 787 simulator. Okay, nothing to see with our vehicle, but yes, there is a common sense. And I have learned how to avoid a collision in the air against another plane. And when you are piloting a Boeing, which is not every day, you have a radar, and where you see a silhouette coming in front of you. White first, no danger. Orange, risky. Red, risk of collision. And then you can react. And I could experience live this device, this efficiency. And when I saw that, immediately I was thinking to motorcycle and the mobility world. When we will have this device where immediately you can detect this risk of collision, we will make another big step in the improvement of the statistic, but behind the statistic, we speak about lives. So we are working in these 4 domains permanently. The 4th one is surely perhaps the more promising to pass another step in the statistic and the improvement, but we don't forget the first 3, which are a permanent effort, and we are happy to see every year, step by step, the number of these fatal accidents reducing, and we know that we have also to take care about the injuries. It will be the next step, but I just wanted to share with you how much we are committed in these objectives and how much we feel our responsibility to serve a better mobility world in the future for our society in terms of CO2, emission, silent, and safety. Thanks a lot.
Thank you. Thank you, Eric. I will not open the floor for questions because if I open the floor on CMC, we will be behind time. What I would suggest, if you can stay with us, that we keep the questions for the exchange, the Q&A section of the program. But you highlighted really what is the different aspects of safety, some long-standing, some looking forward. I think this is really what we want to show with the vision, that this is the direction we're looking forward on many topics. You mentioned also decarbonization, which leads me directly to my only neighbor here in the room, and I'm really glad to welcome Helfried Sorge, Managing Director, CTO Powertrain for KTM, Forschungs- and Entwicklungs, I hope I pronounced this correctly, But before then, he was working at AVL, also in different positions, focusing on vehicle and engine design. So I'm glad you can be with us today. I think you will talk about decarbonization, which is another one of the main fields that were mentioned by Eric de Seine. And obviously, it is also dealt with by Yamaha as you're dealing with safety. I mean, the idea here is to show some examples, and we will bring everything together afterwards. So please, the floor is yours.
Antonio, thanks a lot. Ladies and gentlemen, thanks for having me here in person. I enjoy it very much. And I want to take you a little bit to a small journey to decarbonization of the BIOMED-TEC. And the question is, first of all, who is BIOMED-TEC? It's a holding company of the Europe's leading manufacturers power two-wheelers, the KTM AG. And I just don't want to bore you with these figures, but it should show you that with more than 5,000 employees, we have achieved last year with our premium brands to sell more than 400,000 powered two-wheelers, thereof around 300,000 motorcycles. And we are fully committed to a sustainable future within our business. And this starts in the logistic chain, it goes over the production, and of course it ends, and I'm a powertrain guy, so I need to say that, with the efficiency of our powertrains. So, and I tell you that because it's quite tricky and some sort of a challenge to really be sustainable within this field. You see our three brands we have under our rooftop, which is KTM, Husqvarna and GasGas. And if you see how we have interlinked in a modular way our powertrains into the vehicles coming from the off-road and the competition over the dual purpose, the street, up to the competition ones. And we are pushing our 1- and 2-cylinder engines, the ICEs, and of course the e-drives into all these vehicles in the premium sector. I think we have achieved a lot already in being CO2 optimized. We are in the range of around 95 grams for the entire fleet. And I think this is a good starting point. But it's the starting point, it's not the end. So we are dedicated to the right vehicle, right place, and right energy carrier approach. So this is a clear statement into diversification. And we have 3 points there I want to highlight. First of all, it's the technology openness, which is for us a driver for research and innovation. Prohibition never in history was a good choice. And what we see right now from politics is a sort of a prohibition of the ICE powered two-wheeler, and not a sustainable approach, cradle to grave, with the right energy carrier. So we strongly believe that we should change this, and I think we are on a good way. Maybe a little later we have the one or the other question or discussion point here. So what does this mean, technology openness? This enables competition of technologies, and this is the motivator for new solutions. And we strongly believe that e-fuels can, a good solution, can substitute the conventional gasoline which we have today, 100% or as a blend or whatsoever. So there is a way to get rid of the pure fossil fuel up to 2050. We fully are committed to that Fit for 55 challenge. E-fuels can specifically designed, and I think this is a very good technical point, to increase the efficiency and decrease the emissions on the long term. So for us, e-fuels are not a bridging technology towards electrification. It's not a niche. It's one of the possible routes to go on a long-term run. So you see under point 2, we believe in a multi-pathway to decarbonization of the powertrains for all our segments. So let's start with the performance class below 250 ccm. So we see here a mix of electric motorcycles in the low voltage range. We talk about 48 volts, due to the fact that high voltage systems are still quite expensive. This is not the case for 48 volts. And I think especially for urban areas, this could be, or will be, from our point of view, the right way to go. This is not the case for the higher performance classes. So we think that above 250 CCM, the optimization of the ICE is the way to go. Optimization means new combustion concepts, dedication to synthetic fuels, maybe the help of electrification for the ICE. And I think this will again drop the consumption, would decrease the consumption by a further 10 to 20%. And this 10 to 20% we can gain out of the fossil fuels right now for the entire fleet, and we can also gain that for sure for the e-fuels. So we are investigating, or more than investigating, this on our racing tracks. So from 2024 onwards, we will have a blend on MotoGP with e-fuels, and by 2027, there will be e-fuel only operations on MotoGP. And we are a founding member of the e-fuel alliance, and I think the one or the other has maybe read the press, so we have a breakthrough in having e-fuels as CO2 neutral accepted, not only H2, but also the e-fuel as derivative out of this process. So I'm quite happy about that. This does not necessarily mean electrification is bad. I like and love electrified bikes, in particular ours. And we see each other as a pioneer for the electric motorcycles, and we have in 2014 launched the KTM Freeride E. And with a lot of other smaller bikes, especially for the youth riders, for trial sports activities and other sports models in our portfolio. But we have a clear target. At least we will have 3 multi-product electric platforms launched in 2024. And get duked, I have to say, in this way. And of course, we are a founding member of the Swabian Battery Consortium. We will hear a speech later on. We believe that the infrastructure is one of the key elements for the electrified motorbike, but also the environment or the infrastructure for e-fuels, from my point of view, is the task of the politics. So, this is our roadmap until 2030 and beyond. We are in the middle of the development of this, and in particular I want to give you this example. So it's a clear target to become a global leader of electrified powered two-wheelers in the power range between 250 watts up to 15 kilowatts. And yeah, by 2030, it's a clear target of our company that we have at least 1/3 of the group sales with electrified powered two-wheelers. So, thanks for joining the journey with me. Thank you.
Thank you very much, Elfried, for the. So we're all going to get duked, apparently. Okay, I'm looking forward to that. Anyway, jokes aside, no, this is very important. You underlined many points, which indeed are part of the ASIM vision. So on the one hand, the diversity of solutions, the multi-pathway, which we fully support, with clearly an emphasis on electrification on the lower end of the vehicles because of the diversity I was mentioning earlier. So low range, low performance, densely populated areas, cities, urban mobility. So that clearly will go progressively in the direction of electrification. We, by the way, just read this morning, we as ASEM are becoming part of the expert group at European level on urban mobility, which is, I think, a great opportunity to provide these inputs to the European Commission as we move forward. We were talking about how to create a position for the sector. I think we have many opportunities there. And then, of course, you talked about also vehicles that would have to continue in the next future being operated with fossil fuels for the start, which is clearly already a positive development as such because we emit less CO2 than many of the vehicles that are today. And even if you look in perspective, I would add, and we can come back to that in the discussion later on, if you look at the targets that are applicable for cars in the future, we are already below those. So I think there's a large opportunity to be seized for all at European level, not only the industry, in promoting the vehicles. But I don't want to take more time now, and I will not open the floor for questions, as I said. I want to allow the last speaker from the industry, and then we will have Maurizio Maggiore, as I mentioned, from the Commission. So the third speaker for the industry is Riccardo Tosi, Executive Vice President, Two-Wheeler Product Development and Product Marketing at Piaggio, where he's also heading the e-mobility group. As you were mentioning, this is going to be the main, I would say, focus for Mr. Tosi's intervention. Before being in the current position, he covered different positions at product development and marketing in Piaggio, where he actually also started his career as engine design team leader, powertrain and engineering system. At some point, he had a short digression to the four-wheeled world with Fiat and then FCA as platform manager, but he came back to two-wheelers, which I think is a very good thing, and the floor is yours, Riccardo.
Thank you very much, and good afternoon, everybody. Let's start with some historical information about Piaggio playing in the decarbonization over the years. Piaggio pioneered the decarbonization with the launch of the first plug-in hybrid vehicle in the 2010. It was an MP3 and was able to provide more than 40 kilometers in zero-emission version. Then Piaggio continued with new products, starting with the Vespa Elettrica in the new deal of electrification in the 2018. Vespa Elettrica is the first mass market vehicle that Piaggio launched with the battery, lithium battery on board, and then with the Piaggio 1 last year, definitely entered in the mass market world with a really affordable vehicle, light, compact, with the first swap battery of the group. Then we are preparing new products that will come next in the 2024 on and the following years. These products are coming from motorcycles, then new scooters, and commercial vehicles, because Piaggio is playing in the commercial vehicles field. What's next? The alternative fuels that the KTM colleague already introduced, and the battery electric vehicles are for us the two paths by through the decarbonization and to be solved. The alternative fuels is a recipe really interesting for the bigger engines or the bigger vehicles, because it is really easy and versatile to use, and is suitable for vehicles with more than under 25 cc equivalent and up. Piaggio is already part of the e-fuel alliance, and is pushing this technology because we think that it could help the battery electric vehicle the solution to be the solution for the future. But in the transient period, we want to have two paths and two recipes to play with. The swappable batteries motorcycle consortium is the other way in which Piaggio is pushing the decarbonization. It's a consortium that is leveraging on the swap batteries and the swap stations that are solving some of the problem that now is breaking the battery electric vehicle diffusion. Next. So alternative fuels is for us one of the solutions in parallel to the electrification. It is really climate neutral, and if we take into account the entire balance, and it no need of widespread infrastructure like the recharging stations that the electric vehicles needs today. So it's another solution that we want to take into account. Next, please. I want to introduce you, which is the swappable batteries motorcycle consortium idea. It is a simple chart in which is described which is the procedure that a rider can use to replace the battery. When a battery is empty and a customer wants to recharge it, he or she has just to replace the battery, the empty battery, with a new one already charged, that it charged by a recharging station, which is basically a box in which some slot has fully charged the batteries. So the customer has just to replace one battery with the other, and full stop. So 1 minute will solve the problem of the recharging time. 1 minute is enough to have a fully charged battery on board the vehicle. Next, please. The Swappable Batteries Motorcycle Consortium has basically 4 goals to achieve. One is to create a common spec for the battery system, so a specification that widely all the members can share. The second one is the common usage of the swapping system. So the members submit a sort of agreement to use this way to play with the battery electric vehicles. The third one is the standardization bodies, in which the standard have to be registered. And later on, I will explain where we are, because this is the final goal. So create a standard for everybody. The fourth one is to enlarge the coverage of this standard abroad, so outside Europe, outside the ASEM area. The standardization and swappable batteries of swappable batteries and swappable system, so is a solution to solve the limited range, a recharging time that customers today has. Just move to the members. Today, the SBMC consortium count the 4 founders, so Piaggio, KTM, Honda, and Yamaha, and further 8 OEMs that joined the consortium. On top of this, we have 3 battery manufacturers, 1 infrastructure player, and 7 component suppliers, and many other potential members are applied to be part of this consortium. This is a simple roadmap that describes what happened and what will happen within the consortium. We are in September 2022. Now we have a design of the battery 80% frozen. Now we are starting with 2 paths of validation, one through a clean test in a city with already existing batteries and already existing vehicle provided from the members, and then a prototyping phase for the battery at a level proto, in which this battery will be tested at the testing rigs in order to validate the design. By end of 2024, this design will be completely validated and frozen, and then by the beginning of 2024 and over the 2024, this design is planned to be public and available for the members. Please, next. So just to conclude, the swap batteries provide advantages for customer and for the environment. Customers have a longer range basically an infinite range, because they can replace batteries every time as the battery will get empty. They have no more anxiety for the range, since this battery will be provided at the corner of the streets, so within the city centers, and they will be really a solution to reduce the cost of the vehicle, because the vehicle will be sold without the batteries on board, because the batteries will be provided by the system. For the environment, the advantages are the efficiency of the swapping systems, because they are developed at the center point, so they can provide with the better solutions that many OEMs can provide, and the suppliers. The recycling is guaranteed, and the circular economy too, since a sort of central point will drive the analysis and the management of these tools, and the afterlife batteries is guaranteed as well. This standardization leads to a great technical evolution, of course, because all the players within the two wheels will cope on the same table to design the better solutions. Thank you for your attention.
So again here, thanks for the presentation. This is again aiming at showing what is the vision, I would say, from Piaggio, which is not, I would say, any different from what has been presented by KTM. It's basically, I would say, complementing it. I'd like to move forward to welcoming Maurizio Maggiore, because we've been talking so much about policy, we've been talking about legislation, and clearly we are not at the moment, and this is very important, the motorcycle industry is not impacted by current CO2 legislation that is applying to cars. There is a good reason for that. We are a drop in the ocean, I always say, when it comes to CO2. I hear somebody online, but I don't know. Okay. Hi, here we are. Hello, Maurizio. Welcome.
Hello.
Good afternoon. Good afternoon. So, now, you're welcome. Thanks for joining. I was just saying that we are not touched by legislation, but clearly we are thinking about what we could bring in terms of solutions for the future and how we can contribute overall to decarbonization. And this is the reason why, as I was saying in the introduction to this event, we have in the room here, Maurizio, many researchers. It's a very innovative audience, if you like, and we thought it would be best to have somebody like you from DG RTD to basically also show what is the current view of the Commission. So maybe just more formally introducing Maurizio Maggiore. Maurizio Maggiore is a senior expert at the automotive branch of DG Research and Innovation at the European Commission. He follows the reduction of polluting emissions, the increase in efficiency of conventional engines, as well as electrification and hydrogen fuel cell technology in road transport applications. Previously, he worked in the aviation business at Agusta. I would say the wrong Agusta if I take the motorcycle view. It should be another one, but still dealing with engines and vehicles, and we talked about vehicles that are using mobility and improving mobility. For sure, aviation can do something too, and also in publishing. So without further ado, I'd like to leave you the floor. We are a bit running behind schedule, but I don't think that should be a matter of stress. Please take your time, and if we run a bit late, I'm sure we can count on the organizers' understanding. So, floor is yours, Maurizio.
Thank you, and hello to the audience. Fortunately, I'm not there. I'm connected from Brussels. I'll try to give a kind of brief outlook of the legislation, even though, as just said, it's not regarding two-wheelers at the moment. But I think it's important because since you said you are a drop in the ocean, I think that the developments will be connected. So if you go to the next slide, I will give you a kind of first introduction on the Green Deal, which I think is the reference, is the Bible. I highlighted the areas where transport impacts are most relevant, and I underline that one of them is eliminating pollution. I think that that this is a little bit overlooked when I hear certain discussions, let's say. But apart from that, of course, it's strongly about climate neutrality, but with all the side issues like social impact, impact beyond Europe, mining and all that, it's trying really to cover all the bases. It's not forgetting anything, like sometimes I hear people saying, you forget this, you forget that. You look into the package and there's really almost everything. And whatever is not there is coming because we have some follow-up activity. Next slide. For sure, there's been a kind of political background. I will go fast on this. You know, the climate law, the climate pact involving the citizens and so on. But the centerpiece has been Fit for 55 presented last year. The guiding principles are that we have really to stress efficiency first, do not harm, linked with this zero pollution ambition, and the just transition to look at the social impacts. Next slide, please. So looking at mobility in the Green Deal, it's trying to attack the problem from all sides. So looking at multimodality in order to facilitate the use of the best means for each part of the trip. Look at the potential that automated and connected driving can give to mobility, services, reservation, ticketing, all those things that today sometimes are a bit of a mess when you have to move from one transport means to another, for instance, in public transport. At the same time, we have to make sure that prices reflect reality. At the moment, basically, society pays for problems created by some people and not all. Everybody pays for problems created only from a part. So to make sure that the market really plays a role, prices must reflect it. And of course, in our view, that a lot of that, let's say, passes through the penetration of zero-emission vehicles. Because in the end, they, at the same time, take care of many of these issues. At the same time, this requires an infrastructure to support them, to enable the consumers to have the minimum difference with what is today. I'm not sure we will ever achieve no difference, but I think that in such a big effort, a little bit, a minimum of change should be acceptable. And at the same time, we have to make sure that this is interoperable, that wherever you go, you can use what you have. So standardization and so on are playing a big role. Next slide. For implementing this in the legislation that is included in Fit for 55 and will be included, for instance, here there's no mention of heavy duty, but it's coming at the same, let's say, in the same direction. We have standards for cars that basically the proposal, but I would say now it's more a proposal because whatever the Commission has proposed now has been endorsed by Parliament and Council, at least in the broad lines. So, for instance, the 2035 zero emission date seems to be staying during the negotiation. And this means that we will have a parallel deployment of the vehicle and of the infrastructure. The infrastructure has, let's say, clear targets on main roads, because of course Europe has an influence on legislation on the main roads, the so-called TEN-T network. But of course, these are then going to be reflected by member states on the other roads, I think. Next slide. So I put here what these targets are. There are targets on the, let's say, quantity and quality in terms of power that can be provided by the charging points and at what distance they have to be. And the same is also true for heavy duty, in particular for hydrogen, because at the moment, I think for heavy duty, we are still in a watching phase, because basically the first heavy-duty zero-emission vehicles are coming out now, and which one is really the best, or if both are good, and we will and the market will decide for each application what's the best one. There, it's basically parallel hydrogen and electrification. Next slide, please. As I said, there's plenty of other actions going on. We, as I mentioned, the heavy-duty legislation, there will be a battery legislation. So all the discussion on the sustainability of batteries and the production and so on and so forth will be dealt with by legislation imposing clean batteries as well as clean vehicles. So import from places where the electricity used for manufacturing the battery is not clean will be discouraged or even stopped. And the same in Europe will be promoting clean, let's say, manufacturing of batteries. There will be Euro 7 and air quality legislation being revised. And as I said, this means that the pollution will get a very high let's say, visibility compared to the past. In the past, there were compromises done on to achieve improvement in CO2, which led to pollution. The idea is not to have such trade-offs anymore. And at the same time, and I will talk about it later, we, let's say, are supporting this transition with a very strong R&D support. We have partnerships, which are basically a common funding, a common, let's say, work between public and private on supporting these transitions, on the zero-emission vehicles, on hydrogen fuel cells, and on batteries. So all these, we are talking about, well, the hydrogen is not only transport, so considering the transport part of the hydrogen fuel cell, I think we are well above 2 billion euros in the next years. And then we have a new kind of instrument, which are the missions on climate neutral cities. So cities that commit themselves to become climate neutral by 2030, and we are supporting them to demonstrate, to cross-fertilize, to find synergies. And I think this, I say it already now, I think this is a kind of sandbox where new ideas and new concepts can be tested, let's say. So this is, let's say, the background. What when you look at the implementation, of course, there's a lot of things you have to look at in terms of challenges and potential solutions and so on. But as I said, pollution is a major concern. And I think that there is a misunderstanding when the word zero, that technology neutral is mentioned. Zero tailpipe emission is a technology neutral definition because it's a performance target. So there's nothing basically stopping any technology that can deliver the target to be, let's say, applied. And we have to be clear, exhaust pollution is dominating the effects, and there is also noise, by the way. And therefore, e-fuels, for instance, don't do anything to address them. And I would underline another thing, because there's a lot of stress about Europe. But who is driving, who is in driving seat really in these issues is cities and member states. I mean, Europe, I said, proposes basically to stop selling combustion cars by 2035. There are cities, several and big ones, and some countries which are thinking about banning all vehicles, including existing ones, from 2030. So it's not European regulation that was driving here. And the main cause is pollution. So I think that we have to face this kind of issues because I don't think that the cities will be swayed. I mean, they are under risk of infringement procedures and so on, so they have to do something. Another challenge is for sure the availability of clean electricity, and but not all electricity, because I think we have enough at the moment for a full replacement of the vehicle fleet. The problem is getting it clean. And as I said, it's an issue, but we shouldn't overstate it. There's calculations showing that if all road transport, were electrified, we would be talking about an increase in consumption of something like 15 to 20% in each country, which is something that in 20 plus years, it's manageable. And of course, another benefit is this, that these vehicles can be charged in a way which is flexible. I mean, you have a whole night. If there is a moment where there's not enough electricity, the charging can be reduced and then brought forward to later in the night when there's no more an issue. And let's say efficiency also means that we must be careful about not wasting this resource. And there, for instance, hydrogen and e-fuels have an issue, because to generate 1 kilometer energy for 1 kilometer, you need more or less 4 or 5 times the same energy, the same neutral energy that would need it. I just reviewed recently a study where there was an e-fuel scenario, and we were talking about not even the whole fleet, but a large part of the fleet, 4,400 terawatt hour of electricity needed in 2050, when the electrification scenario was 600. So this means that we would need to commit huge amounts of generation capacity to cover this difference, and basically to achieve the same kilometers run. So I think that the challenges need to be looked at really in a wide way. And the fact that this could be a solution is theoretically possible. But then we have to look at the cost. I mean, the cost of these fuels is foreseen to be cost, not price, in the 1 to 2 euro area in 2050. In 2030, it will probably even more than that. And I heard a few days ago automotive representatives saying that let's say the oil industry, the fuel industry, has not lived up to their let's say capacities, and this guy said it's too late. So I think that before pinning hopes on this solution, we need to see whether there's enough, because if let's say the large part of the car industry goes into zero emission, and I heard another one saying the investments are being done, and it's in that direction, then the capacity of producing and justifying the production will be reduced. At the same time, we have the charging infrastructure, as I mentioned. It's another issue. But for two-wheelers, I think that there is, for the lighter one, the easiest solution will be removable and charge at home. And battery swapping, of course, is another easy, let's say, solution. Whether and how much swappable batteries, maybe in multiple numbers, could be a solution also for larger vehicles and so on. This is an option. The other is to try and use the infrastructure made up for cars, basically, because I think that thinking about a parallel infrastructure might meet some problems. So I heard about work about a smaller plug and so on and so forth. I think that might be a risky direction. Another issue is battery cost, for sure. There is we have to do a lot there, but I think the progress has been spectacular. I remember the forecast in 2010, 2012, and they have been outstripped by reality. Now, on all this, DG Research, and if you can go to the next slide, has been working for a long time. I mean, we've been funding this kind of projects for a long time. Can you go to the next slide, please? Yeah. And we had a series of partnerships, but let's say that this is the one that is really focused on zero-emission vehicles. And as you see, it's the whole gamut of vehicles that we are looking at, including two-wheelers. So it's let's say, across the board. We are putting something like 600+ million in this partnership of funding. And in the past, we funded a lot of projects, for instance, on advanced 2-, 3-wheeler architecture and concepts, and also many on rider safety, not only on the vehicle, but also on accessories, on developing safety accessories. And we will continue to do so. But and at the same time, we have been also looking at light 3- and 4-wheelers, L6, L7. All this is still valid. We had topics on this, and we will have one. I cannot, let's say, put the text here because it's still in the last days of the decision, but we'll have a topic on frugal mobility. So vehicles which are adaptable for advanced countries and emerging countries with basically a basic platform, and then with different equipment and so on to satisfy different needs. And there, for instance, swappable batteries are explicitly mentioned as a potential solution. So I think that there's plenty of work possible and funding possible in these domains. And another area which I think is very interesting is light logistics. I think it's probably less sexy than motorbikes and so on, but I think urban freight applications with zero-emission vehicles is another area where the experience of the two-wheeler world might be brought to bear, because if many kilometers these delivery vans run, and how many start-stops and so on, I think that could be another area where we are welcoming proposals. As I said, the city's mission might be the sandbox where to test this concept. And we have there a joint topic between the mission and the partnerships to really think about a kind of a city-level approach to personal or freight transport. So keep an eye on possible on future calls, because there will be possible funding for new ideas in this domain. So I hope this provided a sufficiently clear landscape of the work we are doing and how and what is behind it. And I'm available for any question. Thank you for your attention.
Thank you, Maurizio. I knew that you would be, how can I say, challenging, because clearly the policy is challenging. But you highlighted points which I must say, luckily, are under indeed the ASEM Vision 2030. They are taken into account. So you mentioned noise, local pollutants. They remain key elements of our vision. It is clear that when you bring them all together, and I understand where you're going. Clearly, especially in the urban environment, we're also aware of the cities. If it's not happening top-down at European level, it's happening bottom-up. It's in the press, and as you rightly say, there are increasing limitations on motorized transport that are going to come from the city level. So this is also part of the reason why we are engaging in this debate. Even though there is no European legislation, we are trying to work ahead of schedule to make sure we can provide what would be our needs and preferences. If I try now to open the floor, and I don't know if we can see all the participants in the round table in one slide, hopefully not this one, but the cameras. Yeah, at least we see some. That's good, thank you. I'd like to open the floor really for for questions from within the panel itself, clearly as a preference, because you've been exchanging, I think, addressing the same challenges. You identified the same challenges. We identified also the diversity in our vehicle fleet, the fact that they can respond to different kinds of usages today, and in perspective, there will be also opportunities. So who wants to start, I would say, with a question perhaps to either Maurizio, I'm thinking about the industry speakers, if there is any particular angle that you would like to deepen on with Maurizio, or the other way around, indeed, Maurizio, you're also free to raise a question if you want. Yeah. And whilst you think about the question, I will also invite the audience, and I see somebody in the audience raising his hand, so I will invite Pierre-François Tissot, I believe. I can't see. Yes, it is. So I'm guessing question on safety, probably. Yeah.
No, not even.
Not even. Okay.
Hello guys.
All right.
Pierre-François Tissot, co-founder of Motion Airbags. But my question is more about when we look on mobility. Today we see, like, for me, the boundaries between scooters, e-scooters, bicycles, e-bikes, scooters, and all of stuff is more or less together. Is how to move on a short distance with something that makes work not fast enough. So how do you see, as like former Pareto wheelers, your position between, okay, strong motorcycles on road, but when it comes to mobility, where is the boundaries, and how do you see your companies having a role in this part of electricals or even muscle-powered bikes?
Okay, that's a good question. Who would like to take it? You would like to, Helfried? Okay.
I can start maybe.
Yeah.
I mean, what I've shown is that I think we fully support the electrification in the urban areas. The speed is not that high, and I think it will make sense from our point of view. We've heard about the local pollutions which can be avoided by electrification. I mean, there is not a sharp statement where is the electrification ending up in a logical way, which is economically also okay for us as a company, but I've pointed out 48 volt would allow, let's say, 15 to 20 kilowatts on performance. With that, you can run around 100 kilometers per hour, dependent on the profile you ride. It's up to 80 to 100 kilometers range. I think this is a good fit for the smaller ones. If you have a closer look to the leisure, for instance, from our house, the Super Adventure, we have here, just for example, 23-liter gasoline on board, 220 kilograms, dry weight, and 240 fully equipped with fuel loaded, and with a consumption of around 5.4 liters per 100 kilometers, you have a range of around 400 kilometers. If you do the equation and convert this into battery with the same range, you end up with 450 kilogram, and then it's not longer a motorcycle. So I think you needs to be diversified in the application of the technology, as said before. So no sharp transition from our point of view.
Okay.
Perhaps I will.
Eric, please go ahead.
No, just to complete the answer about the boundaries. I think there are no boundaries. If I take my company, I know the best. We have been starting to develop and sell e-bikes, so electric bicycle, in 1993. So already 30 years ago. And 25 years ago, when we tried to import them in Europe, nobody was ready. The customers, the politicians, the distribution network, they did not understand the benefit of this vehicle. So it takes time. And today we are considering a PTW, which means power two-wheeler world and market, without any limitation, including e-bikes, up to any performance bike. But again, The problem is about the technology. Today, we want to sell marketable product that the customers can pay and offer. And I totally support the vision of KTM. Actually, the battery performance allow us to consider first urban vehicle, and mainly for two reasons. First is CO2 emission for sure, but also silent. We have also to fight and to control better what is the noise pollution. And the noise pollution is really affecting everybody in the city. So when we are promoting urban two-wheelers, we try to solve these two pollution, silent and CO2. If you want to consider big bikes, today the ratio of performance is not competitive at all in terms of price, in terms of weight, in terms of capacity. Usually I say everybody consider that Tesla is fantastic car, but Tesla is using 800 kilos of battery to transport 4 persons with some luggages. A big bike need to transport 2 persons with luggages, and we cannot embark 400 kilos of battery. We cannot even embark 200. We have to embark 40. So the performance of Tesla battery should be 10 times more efficient to be fully applicable to our product. This is what I have listened carefully all the explanation, and we understand that the politic would like to dream about this world, but there is also a reality, and our consumers want to travel. How do we manage? We have to accept that we will have a transition period where this kind of e-fuel technology or hydrogen can play a role, improving significantly the CO2, but also compensating the lack of performance of the battery.
Thank you, Eric. Yeah, Maurizio, is that you? I can't see.
Yes,
but
I would
please.
pick up exactly where you just left.
Yeah.
You mentioned hydrogen, and that's already another thing. That's a zero-emission technology, for instance. And about batteries, I would look at what happened in the last few years. The first Renault Zoe had a battery that allowed 150 kilometers. 3 years later, in the same exact size, to the point that you can swap the battery and put the new one, you have 400. So I think looking at transition technologies, when there is a technology which is growing so fast that you might have a 200 kilometer or so capability soon, and then you have fast charging. I think that, as I said, I'm not expecting everything to be exactly of today, but a stop of 10-15 minutes every 2 or 3 hours, 2 hours, I think could be an acceptable compromise that, as I say, if the alternative is a 3 or 4 euro per liter fuel, maybe people might think that that is an acceptable compromise.
Thank you. I don't know if there are any reactions to that, but looking, maybe a brief one if anybody has. Otherwise, I would leave the floor to Sebastian Will for another question, please.
Okay. Hi, everybody. My name is Sebastian Will from the Würzburg Institute for Traffic Sciences. And thanks for the insights you provided. All of you touched upon this electrification topic for the urban areas, maybe in the beginning. But Mr. Desen also touched upon that training issue, which motivated my question. Because I think that a major contributing factor to sustainability is actually sitting on the power two-wheeler when it comes to energy consumption, for instance. So my question would be whether you think that this change in powertrain technology, so from ICE to electric powertrains, requires more inclusion of the riders in terms of information campaign or training on regenerative braking and whatever, as compared to the changes that appeared in powertrain technology in the past. Mm-hmm. Thank you.
And this is a question to
Generally, I guess
General
everybody
question.
could answer it. Originally, it was motivated by Mr. Descent's comment on the training.
Yeah. Who wants to reply? Eric, you want to integrate?
I can answer briefly. I think that obviously when you change the transmission, because on an electric vehicle you shift to automatic transmission, and as you know, the majority of the motorcycle and we sell are remaining with mechanical gearbox. So obviously you have to learn how to exploit the capacity of the engine. Mauricio was mentioning the Zoe. I could drive a Zoe, and it's sure that immediately you understand that you have to adapt your way of driving to exploit all the capacity of this technology. So it will be the same for motorcycle. In general, the users we have are very much connected with their bike. They try to feel the bike, and it's part also of the safety. You have to control your bike. So in general, our users are very sensitive, but for sure it will be interesting. And we have been supporting the launch of the first riding school in Paris, using electric scooters, electric vehicle. Unfortunately, they are not so much Yamaha, but at least the initiative was correct. And I have no doubt that we will adapt the offer of education, training, and improvement to the new category of vehicle. So your question is valid, but I think it will not be a big issue. We will follow immediately.
Okay. Any follow-up replies? Otherwise, I see Matthias Möbe from Bosch, if I'm not wrong. There's a lot of light here, so okay.
Yeah, good afternoon.
Yeah.
We've heard in the last 1.5 days, and also in the speech of Mr. Tissot, the potential of connectivity. My question goes to Ms. Maggiore. Is there any means, idea existing in the European Commission by when we will actually see a regulation which also includes the power two-wheelers in the connected world of traffic? A date.
Maurizio.
Yes, I think I see the point. The issue is that the specific needs are slightly different. I think that the technology will allow all transport means to benefit. When I think about the work, for instance, on looking around the corner with connectivity, I think in principle anybody could use it, including and probably even more benefit would be power two-wheelers, because as been said, they are the ones that people don't see. So a technology that signals that on a crossing road something is coming, even if you don't see it, of course would benefit. Now the issue was mentioned about the shoebox on the motorbike. Of course, all this means a space on the motorbike. So I don't think there is a specific need for motorbikes in terms of the implement of the technology, but then how to put it on the motorbike and in an economical way, that might be more of an issue. Of course, if there is, I always use small mopeds and things like that, so I'm not a motorbike using big motorbikes. But if there is something which is specific, which wouldn't be captured by all the work which has been done on safety and connection in the current fora, that might be falling between the cracks. But I think that the large majority would benefit. It's an issue of implementing it on the vehicles.
Okay.
May I add one comment here? I mean, safety is one of the driving factors for connectivity, but there is an additional aspect talking about electrified motorbikes. We're addressing with that young riders, and the young riders, they have the mobiles, and everything which is electric has an association to connectivity. I think it can also be a chance of bringing in this connectivity also in the heads of the young riders, and we strongly are going into this direction. And on the other hand, it enables, by getting neutralized data from our fleet, also the ability to develop our bikes in the future even better than we do today, because you have different load profiles, you have different areas where you go, and with this valuable information, I would say data is the new gold. We can tailor-made our products to the individual user groups in the sake for safety and also pleasure and leisure activities.
Okay, thank you. I see Michele Colanino is on. I support. You need to make a contribution here, or is it?
Can you hear me, Antonio?
Yes.
I'm listening to these interesting questions for the session, but I want to remind everybody that I see, and I think that it's obvious, a risk on all the discussion that we are having in this session. I repeat, I don't see any technology problem in our business and in the mobility field. Technology is there. We can create anything. Ideas are coming. Money are there. There's a liquidity market on the world. So it's not a question of technology. We can reach every target that we want. We don't have to underestimate the social impact. The social impact of the debates that we are taking today, that has two major aspects that must be on the table of everybody, politicians, entrepreneurs, and customers. And when I say politicians, I mean every level of politics. I agree with Mr. Major. It's not EU Commission that is driving the situation. It's state-owned. It's a local authority debate. But when we speak about electric mobility, the cost of a vehicle and the cost of mobility will increase a lot in the next 20 years. And it's not a problem. We are only to be aware that mobility will not have the same cost of today per kilometer. The second issue is on jobs. Building an electric mobility needs 1/10 of items compared to a thermic engine. And obviously, that's normal. And we are seeing it's happening in Germany, for instance, in the biggest worldwide automotive industry world. You need 1/10 of people working on the line. So I'm not afraid of technology. I'm very happy that my children will live in a zero polluting world. By the way, it's not just the automotive world that is responsible for pollution. Anyway, we are debating about automotive and mobility today. And I hope that every sector will have the same attention that we are having today. Because the world is not just mobility, automotive, trucks, or two-wheel. So we don't have to underestimate these when speaking about zero pollution. I repeat, it's not a technology issue. It's our target, and it's our social responsibility as entrepreneurs to reach the zero polluting world. But the cost will increase, jobs will be lower, and this is a transition. And like every transition will be solved, but it's not a tomorrow solution. We take 20 years, I think, and it's our internal debates. We are building robots in US for delivery, for instance. We are building everything. We have every technology that you can use in mobility. But the cost is so prohibitive that customers are not buying. They are not enjoying recharge infrastructure in downtown. You need, 100,000 infrastructure columns to fulfill the needs of Milan, for instance, because you take 5 hours each car or 5 hours each vehicle. So it's a very complicated world where we are facing. I repeat, it's not a question of technology. We can do everything. But I firmly ask, and in my debates in Brussels, I continue saying, please look at other aspects. It's not just mobility, zero emission. This is the easiest part. This is easy to put technology in a vehicle. the social impact, the time needed for such a big revolution. And I repeat, every revolution carry on huge opportunities. So there's an opportunity every day. But it's not easy to say that from 200 kilo for a vehicle today going up to 450 kilos, impossible. Okay, the bikes are that. Cost per kilometer now, we know that electricity cost is creating a lot of problems to people. And it's not just mobility, it's the normal life. And obviously, states are making money on selling gasoline, every state, and they will revert to electricity. So it's a solution, as I said before, Antonio and everybody, that we have to analyze deeply and take very, very attention to all the points. It's not technology. Technology is easy. I don't know what Mr. Majoris think about the social impact that the revolution carry on. Like it's normality. It's nothing strange. I'm not afraid.
I know that there are sectorial, and I'm not pretending. I think the Commission is not pretending that there's no sectorial implication. The impact assessment which has been done, which is public, says that yes, there will be reduction in some sectors and there will be increase in other sectors. When you say that you need 100,000 charging points in a city, that's a lot of work. That's a lot of jobs. And if you consider that behind that you will have to multiply the generation capability, windmills, solar panels, installations, or whatever, that's another lot of jobs. Of course, in a supplier or in a manufacturer, that could be a reduction. But at the same time, I was amazed when I went to China. In a few years, all power two-wheelers became electric. And we're talking about a big country. I'm sure that's created a lot of jobs. Because when you replace a technology, and as you said, it's not tomorrow. So we can spread this over time and therefore prepare all the needed components. At the same time, I see sometimes some curious statements, because when we talk about cost, yes, electricity at the moment, and I hope it's not long, but of course we are working in a war environment, so I cannot make a forecast, but sooner or later we should be going back to a more normal environment. Electricity in principle is at the base of e-fuels. So whatever is the price of electricity, e-fuels will cost several times. So I think that we have to be careful about designing a future where the steps, that we have all the steps more or less clear. Of course, the farther they are, the more fuzzy they might be. But I think that the whole chain has to be looked at. And as I say, for some chains, we know where we are now. We know that we had a huge increase in performance. And for me, it's fair to expect similar improvements in the future. And at the same time, this war has taught us that we don't want to, let's say, depend too much on someone. So there's a lot of work, for instance, on finding national, local, let's say, European or not European, but in safe places, let's say, places that we can rely on for having all the material. But for instance, the electricity, we can produce almost all locally or in the neighborhood, so to say, considering sea generation, windmill generation in Norway and things like that. And And that would be, I would say, a safer world if we achieve that, rather than depending for oil from someone, from gas from someone else, and in many cases, not very reliable suppliers as we have seen. So I think that we could have plus and minuses. Nobody is forgetting this. But I think that overall they might compensate, and we have the time. Sometimes I hear, let's say, too much focus on today, and not enough long-term view on the landscapes for energy, for transport, and so on and so forth. Of course, as I say, there will be, and I stress in the Green Deal that there is a social dimension already. So helping lower income segments of the population to cope with this with some support. For instance, coming from the increased taxation of the polluting fuels or energy. It's a matter of balance, and the balance is made possible also by the time horizon. We are not doing it overnight.
Please. Yes, please go ahead.
Get one comment.
And then I have a question here. A lady has been waiting for a long time, so sitting down. Okay, please.
Maurizio, following up your statements here, I think I want to bring in that there is currently not enough energy available by our own in Europe. This is the case for Germany, and this is even the case for Austria, where I come from, a small country with a lot of energy coming from the water and other neutral devices, I have to say, but it's absolutely clear the power supply by electricity now and in the future cannot be covered by ourselves. There's no way. You can put PVs everywhere and increase the supply by wind and solar, but this won't be sufficient. So, and this is the reason why we strongly believe that maybe being independent, going into different countries and install their solar factories on a big scale and produce out of that H2, convert it into synthetic fuels, is a much better way. Because maybe you know what is the efficiency of the biology in the world is the photosynthesis. Okay, the efficiency of the photosynthesis is 0.2%. But it's a matter of fact that the sun is available all the time, and therefore the efficiency is not decisive. So if you go into countries where there is a lot of sun, the efficiency chain is not decisive. It is decisive when it is limited. For instance, here in Germany and in Europe. So, I've always thought that the task of the politics is to set a framework for this sustainable mobility and not define the technologies. How they achieve this fit for that I see it in a different way. Sorry, I've carefully written the Fit for 55 paper, and you're telling H2 is CO2 neutral, and the derivatives out of a neutral ingredient is suddenly not CO2 neutral. This is not very logical. So, I mean, isn't it the task of the politics to ensure the basic supply of the energy sources and the associated infrastructure, as Michele has pointed out? This was my question.
Maurizio, a brief answer, because I know we're running over time and there's somebody waiting for a question.
I try to
please.
highlight a couple of points only. It's a very complex discussion. As I told you, I had a study that I reviewed recently, making a scenario with not even full e-fuel use, with very optimistic, let's say, assumptions on consumption by combustion engines in 2050. I think a bit too optimistic. And they arrived to a level of 4,400 terawatt hours. Now, I did, and you say, well, who cares? It's if it's inefficient. Well, the point is that I did a quick back of the envelope calculation, and I would welcome any expert, I'm not an expert in these things, to do it again just to check my data. My results were that to have the difference between 4,400 terawatt hours and 600 or less, which is the equivalent number of kilometers for electric, you needed to use all the production of windmills for the next 20 years. This is basically to supply, to cover this inefficiency. Now, this means that there wouldn't be windmills left to decarbonize anything else. Or you need to, and by the way, there is all this concern about raw materials. Well, and windmill has tons of rare earths in the magnets which are needed for it, because you need it to be as light as possible because it's at the top of a pole of 100, 150 meters. Now, this is, let's say, to me, is not realistic. I mean, they cost so much, because the other point is this, is cost. The best forecast are for 1.52 euro per liter cost. No profit, no transport, no taxes. So, it has to be sustainable from both point of view. And at the same time, if we have 600 terawatt hours to be generated in Europe, you mentioned national point of view. I think that's the wrong scale. Because if you are in a country that, I know the situation in Germany where the wind is where the industry is not. So I think that a solution there will be better connection, including between sunny countries, windy countries, and other countries. I think that and of course into that there might be a part of hydrogen. The point is that hydrogen will be needed for steel, will be needed for chemicals, will be needed in other areas where there's no electrification potential, and therefore there will be competition also for this resource. So I just made an example of something where in theory all is possible, but the question is then what the side effects are also in that case. So wherever there is an electricity capability, generation capability, which is maybe not in Austria, but it might be in Greece, and you just have to connect better, because there are already connections, but more capability for power between Greece or northern Norway, where there's plenty of wind, and all these things. Of course, it's not today, but we don't need it today.
Thank you, Maurizio. I'm conscious of time, and I'm looking at IFZ organizers because I think we're running late. I'd like to take at least one last question because you have been waiting a long time, and then I'll draw to a close, please.
Yeah, I just want to challenge a bit with a wider perspective. I'm Marilyn Nugent from the University of Florence. I've been working the last few years on PTW safety and more recently on VRU safety in general. And I've been involved in the last year and a half with engaging with stakeholder groups, particularly vulnerable road user advocacy groups. I just want to mention that I read a study years ago that cycling was the most fuel-efficient form of transportation on the entire planet, even looking at animal species locomotion and their energy demands. I know that in business, to be a sustainable business, the focus must be on the customer, not on the product. I know that there's sustainable development goals that address the issue in developed countries of epidemic obesity and lifestyle health disorders, which presents a huge cost to national governments. I know that cities are more and more moving towards not just a mandate to reduce noise pollution and emissions pollution, but to reclaim roads that were co-opted by the automotive industry starting back in the 1900s. And so now there's a large movement on to redress this disenfranchisement of people from safe use of streets. And there's many, many initiatives going on. You can just Google about greening cities and removing traffic hazards so that people can be encouraged to walk and cycle and play safely. So I'm very concerned that there's a gap between industry and what the current customer is evolving into. Also, I understand that fewer and fewer young people are looking for driver's licenses. So I would suggest that maybe there's an opportunity to refocus initiatives and not talk about ways to address increasing fuel consumption needs, but to address the issue that if we reduce consumption, it makes a healthier planet, it makes healthier individuals, it makes happier people in more community-centered cities. And I'm just a bit concerned that industry is not taking a critical view of what is going on and what humans are asking for now.
Yeah, thank you.
Sorry, one little thing, the issues of equitable mobility and gender-balanced mobility options is also important.
Yeah.
A lot of the initiatives that and the developments that go on in R&D for transport are focused on the needs of men to get to work. And there's a big gender gap because many women have different mobility needs at different times of the day. They have to do multiple errands and caregiving services, and this has been highlighted recently as being not addressed as well. Thank you.
Thank you. It's almost leading me to, if I could respond and actually draw to a conclusion. But before I do, I'd like to ask if there are any last thoughts, inputs that you would like to bring to all of you on the panel before I do that. Again, I know we're late, so it looks like it's not the case. Then I will draw to a conclusion. I appreciate a lot your last point because I believe this is what the evolution of the transport system is aiming at. So becoming more inclusive, making all vulnerable road users part of the system, and rather than, I would say, side effects or victims is not the right word, but I mean people that are not thought about in the design of the solution. So I think that's a good point, and I know that Europe is definitely taking that angle. So that is clear. We want to be, as motorcycle industry, and I believe as a sector, we want to be part of that future, and this is undisputable. I just take a few words that were said, and I'd like to use these. I think there are 5 words here on my list to try and conclude. We talked about diversity of solutions, diversity of vehicles. We know we have a lot to bring. We have different vehicles that can answer different needs. This is a real plus of this sector. We talked about bicycles even. We are, contrary to the car, a very much more specialized, lighter, smaller vehicle, which has a lot to bring today and in perspective. It's an issue of seeing, of course, opportunities rather than challenges. I think Maurizio was also clear, and we're also clear in our vision, that whilst we develop the vision today, it is a vision about the future. And this is important because as soon as we know that we are striving in a certain direction, we have time to make the change. It is not about making it overnight. Another point that was made was on the SDGs. This is also very important, the Sustainable Development Goals. These are at the, I would say, at the heart of UN, I would say, resolutions, and in general, also now becoming a key part of the EU development. Any new legislation is based on the SDGs, and so is the vision by the industry. We have looked at the SDGs, we took them as a starting point for the development of our vision, so I think here again we are converging rather than diverging, and this is also good. We identified many challenges that we are aware of. Some of those are going back in time. They've been addressed largely, as Eric was saying, safety. Huge improvements have been achieved, and we are still working. And if you look at the environment, it is the same thing. We achieved huge improvements, and we are still working in that direction. When we look at opportunities, because this is the thing that I believe as a moderator, but also as an ASEM Secretary General, which is important, we have to think about the opportunities that are there. So challenges have been identified. It's going to be difficult, it will take time, we will have support for research, we will have the understanding, I hope also from the institutions, that a large part of our products moving to electric, the urban ones, are actually going to probably make the most of the effort that we can make in the direction of electrification. That's going to be a huge part of our business, moving to electric at an horizon which is not that distant. Probably allowing many more citizens to access electromobility at a cheaper cost that they would otherwise if they were to think about buying a car. So again, here, opportunities for us, but also for policymakers to try and encourage 2-, 3-, 4-wheeled small vehicles, which can be used also for not only moving people around, but also for moving small goods. This is the other point I think Maurizio was mentioning, the opportunities that are lying with small logistics. There's a lot of potential for this sector to really bring an answer which is not existing today in this field. And that will be of major interest to the cities, which, as we saw, are also influencing this debate. The Commission is, I would say, with a certain level of responsibilities, they can act on a certain level, but for the rest, it is the cities. So again, here, from my side, in closing this event and thanking all the speakers that have intervened, Maurizio, thank you for joining and making your time available. Thank you for colleagues from the industry that have taken the time to bring your perspective, your company's views that are perfectly consistent with the vision, and I believe personally perfectly consistent also with what the institutions are looking for. We simply need to give it time, recognize that we have a different size in terms of a sector compared to the car industry, so that also needs to be factored in. And on that, I'd like to thank all of you here in the audience and online. I couldn't take any questions from the online audience, I'm sorry for that. Thank the organizers, the translators, for taking the extra time to be with us and doing this job. I found it very interesting. Thank you very much. Wish you all a nice end of the afternoon. Thank you.
Thank you.
To those who ride them, powered two-wheelers, or motorcycles and mopeds, are loved for obvious reasons. Value for money, time saving,